So the comments I still cannot see. So let me update and refresh the comment screen. Maybe there's a technical problem. So let me explore that technical problem. Yeah. So I guess it's resolved and I am here. So just let me put this pinned message away. Yeah. Good evening, everybody. Good evening. Let us start the process now. Good evening again. I hope I have good. Acha, I have this I have this energy of wishing a good evening generally because at PWJ English channel we have been going live in the evening and afternoon time. So I beg your pardon for that. Good morning, everybody. Good morning, Jenny. Good morning, Arun. Good morning, Bhavna. Good morning, Arun Krishna. So thank you so much for the class. Bhavna, I have not yet started, but yes, Bhavna, I am telling you one thing. With the experience of helping students and touching more and more lives, that too, especially those students who are more comfortable studying in English medium, because obviously, maybe few of you must be comfortable with Hindi language as well, so you must be good with that English channel. But we have one takeaway, we have one advantage from literally whole of the platform that exists. What is that advantage? The student count that we have is quite serious, so we are not over flooded with those messages, and whatever doubts you have, you can clearly put that doubts, and the probability of that doubt taken by a teacher, that means by us, is super high. And that's why we have seen in the live discussions that we have done in the PWJ channel, there were many students who were not even capable of attempting JE properly. They have scored 98, 99, 98.5. I remember the student named Black Mystery. I do not even know him, but he has scored 98 point something. I mean, he may even land to an NIT at a later stage of JOSA counseling. So yes, with that intention, I'm here at PW NEET English channel as well. And today we have our D-Day for the NEET examination on the 3rd of May. So what I'll be doing over here is, yeah, good morning, everybody. Take out your pen and copy. Wishing is done. I have confidence in you, sir. No, you will make me crack NEET, sir. Thank you, Arun. So Arun, you have given me so much of good initial motivation. So with that motivation, let us quickly charge to our today's job. Today's job will be, what are the topics that will be finishing? Obviously, as you can see from the time from the tagline, that we are going to discuss complete physical chemistry. Do not worry, was suffering from the problem. I very happy to have this feature quality at YouTube. Beta, Bhavna, thank you. Now, increase voice, sir. Beta, my voice is, I mean, just for mic check. Guys, I'm audible. I'm audible. Hello. Am I audible to everybody? Now voice is increased. Yashwant, chalo. Chalo. So what will be our topic of discussion today? Beta, first we'll be doing mole concept, because this chapter definitely lands you with one, maybe two questions, but all the physical chemistry questions, every NEET aspirant, most of the NEET aspirant get stuck. So we'll be discussing mole concept, we'll be discussing questions and all the probable questions. I mean, those questions are definitely, the concept is definitely going to be there in your NEET examination on Sunday. I am assuring you this. But yes, mole concept is the foundational chapter. So first I'll be dealing with this, then I'll be dealing with redox also, because mole concept is coupled with redox in JE also. NTAs has done this. So in NEET, I am telling you it will be mixed. So along with mole, we'll do redox also, and because in mole concept we'll be doing concentration terms, so we'll be finishing the chapter of solutions also. So that colligative properties also we'll do. And then we'll come to atomic structure, because all these physical chemistry chapters are of high weightage. So by and large, these 4 chapters is our today's target, because they constitute the most number of questions from your physical chemistry. I hope. Now, sir, what about the remaining chapters? The remaining chapters we'll do tomorrow. So that's why I have broken this live into two halves. First half will be today, and tomorrow also we'll be meeting around 11, and in that we'll be covering the later chapters of physical chemistry. So I hope the target is done. Everybody take out your pen and copy. So hello, let me read out those names which will be going to their dream government medical colleges. So finally, we have Padmana with us. We have Cecily with us. Beta, good morning. Then Dora is asking, sir, important concepts or full chapter? Beta, only important concepts. Why we have to read the full chapter? We are having NEET examination on Sunday, on 3rd of May. So we are not required. We are not here to do everything. We are here to do the relevant thing. We are here to do the smart work. So take out your pen and copy. You will do. Yes, beta. I'll do organic chemistry. What I've specially done is I'll be doing physical over here, and I'll be pushing strategy videos, including all the top concepts. So like for today, you'll be getting a strategy video. I mean strategy as in it will be containing concepts only. The inorganic concept, beautiful concepts of chemical bonding I have combined into around 20-22 concepts, and I have pushed a 20-25 minutes video. But yes, that video is quite fast. So after finishing this live, go to the video section. It will be posted today. It will be having all the complete concepts of chemical bonding, which will help you to do your inorganic side of chemistry as well. Hai only important logic. Dharma duration will be somewhere around 4 hours. What we'll do is we'll break into two halves. 2 hour we'll do like somewhere around at 1 p.m. we'll be taking a break, a bio break for like 10 minutes, and then we'll be meeting again. So we'll be finishing by 3. Before 3 you'll be finishing. Chalo. Now without further ado, let us start. So I'll try to cover whole of chemistry. So first 2 days today and tomorrow is dedicated for physical chemistry. So take out your pen and copy and keep on attempting with me with that intention. Let's start, guys. So your first question, I'm giving you, I'll be attempting with you, so don't worry. But yes, we are giving 1 minute, 60 seconds. So I need answer, guys. Quick. Let's start. Don't worry, I'll be discussing all the logics also. I will not be just solving question. I will be discussing theory also, so that the students who are at 0 will also be able to attempt. So I hope you are attempting this question. Good. But beta, be very responsive. I need answers, huh? I need answers. Chalo. So I hope few of you have attempted this. Chalo beta. Now I will be discussing in detail, so don't worry. The question says 1 mole of atom X has mass this much times of 1 mole of atom of Y. What is mass of 1 mole species? And mass of 1 mole species is called molar mass. So that means molar mass of X is given out to be 0.444 times of molar mass of Y. This is the first thing that is given. Now atomic mass of X is this much times atomic mass of C12 atom. Now this is a very huge amount of attention over here. Atomic mass of X is equal to 2.96 times the mass of C12. Sir, what is mass of C12 isotope? I hope everybody remember the definition of relative atomic mass. Relative atomic mass is nothing but atomic mass upon 1 by 12 into mass of 1 C12 isotope, and that mass of 1 C12 isotope is given out over here, and everybody should know this theoretically. If you do not know, please know this, that this denominator is also referred as 1 atomic mass unit, and in this time it is referred as 1U. So because question is giving me mass of C12 isotope, so it will be 12U. So that means atomic mass of X is 2.96 times of what, sir? Of C12 isotope, which is actually is equal to 12U. So ultimately you have got atomic mass of A. Sir, because this is saying it is an atom, so what is the atomicity of the element? Sir, it will be one only. So this molecular mass of X is mass of 1 mole. Mass of 1 mole is in gram. Mass of one species is in U. So this is mass of one atom of A in U. If I convert it into gram, it will become molar mass of X. So mathematically, I'm not thinking of the unit, then I can equate this. That means this value I can put over here. So 2.96 into 12. What is 1 U in terms of gram, guys? Okay, why converting into gram? Because it is asking us in U only the options. So into U is equal to 0.444 times of atomic mass. This molar mass of Y can be written as atomic mass of Y. Why? Because let's say I have carbon. So one atom of carbon, let's say one atom of carbon has a mass of 12U. So what will be mass of 1 mole of carbon atoms at 12 gram? So ultimately we just have to work on the mathematical term. So now this is simple case of into divide. So I hope you have cracked the answer. Let me, yeah, into divide is a piece of cake, beta, is a piece of cake which you can only outperform once you are practicing it. Arey, we have got no responses. Who has given the correct answer? I hope the poll is working. Guys, you are getting the poll. Question attempting strategy, sir. So after solving where you are going to land, you are going to land at 80U. I hope everybody is clear with the question. Perfect. Chandra Bhushan has given us the right answer. Good, good, good. Moving to the next question. Attempt this, guys. Attempt this one. Now, I guess poll is not working for us. So let me again try it for one, because in the previous poll, I haven't got any responses. So maybe the poll is not reaching you. Not to worry, you can put your answer in the comment section. I mean, we are here to practice. Chalo. But yes, if I would have got that response, I would be happy. But maybe technology is not helping us today, or maybe it will be doing in the next question. Chalo, let's attempt the next question. I hope few of you are getting the answer. No worries, Arun. No worries, Arun. Arun, no worries. At least you are here. At least you are revising. So all the students who are here to revise, please keep on attempting with me. And all the students who are not comfortable with the basics, then you should obviously attempt with me only. Anna, do not worry about writing all these things, because sir, I need these questions, that question I missed, I need to revise it. Once the class is done, you have to go to PW NEET English WhatsApp channel, and the complete lecture notes will be given to you free. I mean lecture notes as in these questions. So don't worry, because I have specially selected this question. They are most probable logics also, beta. Chalo. Moving to the next question, the question says number of atoms present in, sir, very simple, 49 gram of H2SO4. So first what you have to calculate, 3. Perfect, 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 Bhavna. What you have to calculate, sir, number of moles of H2SO4 can be calculated as a weight of H2SO4 upon molar mass of H2SO4. Weight of H2SO4 should be placed in gram, which is given out to be 49 gram. What is molar mass of H2SO4? Sir, it is 98 gram. That means this is half moles. If I have 1 mole of species, what is the number of existing molecules? Sir, it will be 1 mole, which is Na. So in terms of number of moles, in terms of number of moles is equal to number of molecules upon Avogadro's number. So here I have to designate the number of molecules first. So the number of H2SO4 molecule will be Na by 2. But in the question, they are asking us the number of atoms. So we have to multiply with the atomicity. You tell me, 1 molecule of H2SO4 has how many atoms? Sir, 4 oxygen, 1 sulfur, so 5, and 2 hydrogen, so 7. So one molecule how many molecules I have? Na by 2. One molecule has 7 atoms. So this many molecules will have this number into 7. So this will be my number of constituent atoms. So option is obviously option 3. Chalo, perfect. I hope everybody is clear with this, guys. Chalo, moving to the next question. Attempt. Let me see if I've got the poll, or you can attempt this one. I'm just checking that for previous answer. Nahi beta, poll is not working for us, so no issues. But it is saying 27 students are here. Chalo, technology is not helping us. What shall we do? Chalo, no worries. No worries, no worries. Chalo, next question, guys. At least I can see you in the chat box and you can put in yes. Everybody, most of you are getting the right answer. So let me attempt this one also for you. The question says 11.35 gram of gas at STP weighs this much. So for number of moles in terms of weight is equal to weight of substance upon molar mass. Number of moles in terms of volume occupied by gas at STP is equal to volume occupied by gas at STP upon molar volume, which is at STP is equal to 22.7. Yes, it may be 22.4, 22.7, whatever, because technically at 1 bar it is 22.7, at 1 ATM it is 22.4. So rather, let us take 22.4, because for NEET examination, NTA generally considers as 22.4. That means at 1 ATM. So no worries. So this is at 1 ATM STP. Weight is given 14 gram. Molar mass of the gas we have to determine. Volume occupied by the gas is 11.35, and what will be its molar volume? 22.4. So you just, I mean, it is clearly seen that this is 2, so molar mass will be 28. So how many of these have 28 molar mass? Everybody can see nitrogen 14 into 2, and CO 12 and 16. So both of them has 28 molar mass. So your answer will be option 4, not these. I hope everybody is clear. Yeah, perfect, perfect, perfect. Moving to the next question. Answer, guys. Sir, worried about chemistry. Need above 120. Beta, just keep on attempting. More and more you practice, more and more you are going to crack your NEET examination with whatever dream score, with whatever dream college you are aiming. But yes, you have to be keep on working, guys. Chalo. I hope this question is quite doable as well. Good morning, Robin. Okay, Chandra is saying option 1. Jyoti is saying option 2. Atharv is saying Rubina hi. Atharv hi. Stop doing this. Go to your medical college and then hi each other. Chalo, moving to the next question. The next question says the volume occupied by this much gram of CO2 at STP. Again the same thing, sir, but yes, this is just a NEET question, beta. They are asking this. They have even asked this type of things in JEE examination this time. So for NEET, very probable question. So what is your thing? Practice. Yes, everybody's right. So because just the same formula, weight upon molar mass is equal to volume upon 22.4. So I hope 2 is the right answer. Perfect, perfect, perfect. Moving to the next question. I need answer, guys. Next question. Sir, you won't teach concepts. Beta, I have been teaching concepts. Because why I have skipped that question? Because weight upon molar mass is also number of moles. Volume occupied by gas upon 22.4 is also number of moles. So number of moles, I have the formula we have already discussed. So the concept is already discussed. Now we are practicing questions. So I'll be discussing concepts also, beta, that I have been doing. So K is K2Z. I hope you're clear. Hello. Moving to the next one, the question says, which one of the following pair of gases contain the same number of molecules? Sir, if you contain the same number of molecules, then you should have same number of moles, because number of moles is equal to n upon Na. Sir, this is constant, so number of moles is proportional to number of species also. So if you have same number of molecules, then you should have same number of moles. So let us calculate number of moles. Number of moles over here is 16, which is weight upon molecular mass is 32. This is 14 upon 28. So here number of moles is half. Here also it is half. So because moles are same, so obviously if we have got the answer, why shall we reinvest our time to attempt it again? So perfect. Everybody has got the right answer. Moving to the next question. Perfect. Perfect. Jyoti. Perfect. Arun. Perfect. Chalo, moving to the next one, guys. Now, the next question says a bivalent. Now, it is also saying the question is only saying that metal is bivalent, as in its oxidation state will be +2 whenever it is forming a compound. Now, has atomic mass this much, the molecular mass of the metal nitrate. Metal has oxidation state +2. So, what shall be the formula of its nitrate? Sir, MnO3, nitrate ion is NO3 minus, so 1 will come over here, and metal has oxidation state +2, so 2 will come over here. Now this is just plus minus, but yes, atomic masses you have to add. Atomic mass of metal is given out to be 64, plus nitrogen is 14, so 14 into 2 is 28, plus oxygen is 16. 16 into 3 is 48, but 48 into 2, because I have a 2 over here. Just add this, and yes beta, you have to be very quick with the calculations. So perfect Robin, answer is 4. But yes, you have to practice things more and more so that your calculations are increased. If at all beta you are making 1, 2, 3 questions more than your peer, those 3 questions are going to increase your AIR by anything. Beta, after AIR somewhere around 7,000, 8,000, 1 mark, even I have not attempted a question and one person has attempted a question and got a negative -1 from that question, it creates, after 7, 8,000, it creates a difference of 1 mark, creates a difference of 2 to 2.5 thousand. That means your college from a government college can become a private institution. So please practice as much as you can. Moving to the next question. Come on. Perfect. We have got our people. All the serious people are here. All the people are here who are going to land to their dream government medical college. But yes, keep on working. Chalo. The question says, if mass of one atom is this, sir, one atom, as in this is atomic mass. This is atomic mass. If mass of one atom is this, then calculate number of nucleons. What is nucleons? Nucleus has protons and neutrons. It is telling also neutrons and protons. The summation is called nucleons present in 2 atom of the element. Now, because it is saying one atom, so I guess this is a misprint. It should not be gram. Yeah, or else no, the question is given in grams, so not a misprint. Then we have to convert. Sir, but mass of one atom is in U, so we know that 1 U is equal to 1.66 or maybe 67 into 10 raised to the power minus 24 gram. So sir, mass of one atom should be in U or AMU, which is this, but the question is given in grams, so we have to convert this gram. So 1 gram will be equal to 1 upon this much U. So atomic mass given is 3.32 into 10 raised to the power minus 23 upon 1 gram is how much U? Sir, 1.67 into 10 raised to the power minus 24. Now this will come into U. So this will be atomic mass of one atom as in U. So let us calculate this. I guess you can clearly see this is twice of this will be, because 1.5 is 3. So 1.67 will be approximately that only. So this will be 2 into 10 raised to the power, okay, 10. So this is 20. So atomic mass is actually 20 U. Now, what is atomic mass, sir? Atomic mass is generally equal to number of nucleons that you have, because mass of neutron is approximately equal to mass of proton. I hope everybody know it. So ultimately, I will be having 20 nucleons in one atom. it is asking for 2 atoms. So one atom is having 20 nucleons, then 2 will have how many nucleons? 40. But there are only 2 atoms, so not 40 Na. 1 mole will have 40 Na. 2 atoms will have only 40 U. So I hope everybody is clear. Yeah, perfect. Sir, आपके जुड़वा भाई भी हैं क्या? जुड़वा भाई भाई चलो, no joking. Sunday you have your paper, you give your paper, and after that when we'll be meeting in the celebration day, then we'll have cracked these jokes. So for now, please do attempt beta. Chalo. So I hope everybody has got the answer. Moving to the next one. I'm moving to the law of chemical combinations, because NTA has got lot of interest in asking theoretical questions also, because theory takes time to read. So whoever of you students are having good reading words per minute speed will be getting a huge advantage. Sir, I have very low speed. Then practice will increase your accuracy also, it will increase your reading time also. Chalo. So we are serious as logged in. Chalo, perfect beta. Haan, yes you are. Yes, Varsha, I completely agree. Answer this. I need answer. This is a easy, attemptable theoretical question. Hello beta. Hello Yogita. Chalo. The question says, percentage of copper and oxygen in a sample of cupric oxide obtained by different methods were found to be same. That means I have prepared a compound by different methods, but the composition of constituent elements are fixed, same. This is nothing but law of fixed or definite or constant proportion. I hope everybody remember this. Yeah, hello Ekaf from our JE channel, from our actually Laksh group, Laksh JE batch also. So Ekaf, do your DPP, we'll be meeting in the evening. But yes, very good to see you. Chalo, moving to the next question. चलो सर, आपसे पढ़कर बहुत अच्छा लग रहा है बेटा, मुझे पढ़ा के बहुत अच्छा लग रहा है. You know what? Keep on attempting, guys. But yes, you know what? Dr. Yogita and everybody, beta, once we practice more and more in an environment which is exclusive, that is competitive, that is serious, students, we can definitely see in the comment section we are not over flooded. That means we all are serious over here and we are getting answers also. Perfect, perfect, Jyoti. So this will automatically make a compassionate and a cohesive environment where everybody will be growing, no matter how many days we are getting, no matter whatever marks. Let's say for example, let's say I'm getting 500. Let's say without this I'm getting 500. If I'm practicing, at least I can make one more question. My marks will become 504. So ultimately what I'm doing over here, we are here to enhance ourselves, whatever be our state. I'm not saying we all are 650 or 720 over here. Whatever our situation is, if we are practicing, we are enhancing ourselves, and that is our job throughout our life actually. So the question says, nitrogen form 5 stable oxides, as in this. Here oxidation state of nitrogen is +1, here it is +2, here it is +3, here it is +4. So obviously the acidic nature of the oxides are also increasing. A very famous point you should remember, in organic term, these two oxides are rather neutral. So very famous inorganic concept, but now it is asking the mole concept behind it. Now the formation of these explains what? If you fix mass of one element, then the mass of other element combined with the fixed mass of the first element bears a simple ratio. So this is nothing but multiple proportion. Everybody is right. Robin, MS Cat. Beta, your names are very difficult to pronounce. Roman, Roman is good. Chandra, everybody is correct. Moving to the next question. Hey, we are not wasting our time by this putting this polo. Everybody knows that you are attempting at the maximum capacity of yours. If you're not, then please Pen, copy, screen. The moment question is there, start attempting. No waste. Put your phone aside. If you're seeing this in your phone, then don't put it aside. Otherwise, chalo. Hello, chalo beta. Moving to the next question. The next question says a compound has hemoglobin-like structure. Now, what is this type of question? Calculation of minimum molecular mass. Minimum molecular mass. Yeah. So Subhashri, good morning. Chalo. So a compound has hemoglobin-like structure. Okay, sir, we do not know its molecular formula. It has 1 unit of Fe. What is atomic mass of Fe? It is 56. It contains this much percentage of Fe. So the approximate molar mass, approximate as in minimum molar mass, because the question is saying it is having 1 Fe. So if 1 Fe is there, how can you calculate the molecular mass? It will be minimum only because the constituent atom is minimum. Minimum Fe is 1. So mass of Fe upon mass of the complete compound, let's say the mass is m, that will be our desired molecular mass, into 100 will give us the percentage of iron, which is given in the question. So now it is just you have to put in the values. So let us put those values. So weight of Fe is given to be, I have 1 Fe and 1 Fe has atomic mass of 56. Molecular mass I do not know, into 100 is given out to be 5.6. So you just have to do your calculation. So be quick with your calculation, guys. I mean, this is getting cancelled only. So a 10 will come in the denominator. So this is nothing but 1000. I hope everybody's clear. Yeah, perfect. Moving to the next one. Now, again, perfect, everybody. Now, moving to the next question. Again, here we are discussing the next topic. The next topic from Mole concept, the famous topic is determination of empirical and molecular formula. Empirical formula is the simplest formula, and molecular formula is the formula which gives you the exact number of atoms present in a molecule. How to calculate empirical formula? There is a pattern. First, you have to know what are the elements present. So, what are the elements present? These are the element present. Now, what the question may give you the percentage also. The question here, it is giving you ratio also, so no worries. But most of the student make mistake over here. In order to calculate mole ratio, first you have to divide by atomic masses of the element. What student do? They divide by molecular mass. Don't do that. Most of the student make this mistake. So carbon, hydrogen, nitrogen, what are the ratio? 9, 1, 3.5. Because here also empirical formula also I'll be taking the ratio. So why bother? So this is not the exact thing. It will be some 9x. Beta, if you divide, it will be getting cancelled. So because I'll be taking ratio only. So 9 is to 1 is to 3.5. Now what else? Divide by the atomic masses. So this is 12, this is 1, and nitrogen is 14. So the mole ratio will be, this will be 3 by 4. This is 1, and this is this is 7 by 2, no? So this is 1 by 4. This is 1 by 4. After doing the mole ratio, what is the smallest among all these three? So this is 0.75, this is 0.25. So this is smallest. So divide 1 by 4 by everybody. So 1 by 4 by 1 by 4 is 1. 1 by 4 upon 1 by 4 will become 4. 3 by 4 upon 1 by 4 will be 3. So this, we are doing the calculation of simple ratio. And what is the simple ratio? So simple ratio will give you the empirical formula. So empirical formula is C3H4N1. Now, how to calculate molecular formula? Sir, molecular formula is some integral times of empirical formula. This is my empirical formula. How to get the value of n dash? It is molecular formula mass upon empirical formula mass. Now, molecular formula mass, I guess, is given in the question to be 108. And what shall be empirical formula mass? So 12 into 3 is 36, plus 4 as 40, and 40 plus 14 is 54. So this is 54. So that means this is nothing but 2. So molecular formula will be, let me write that molecular formula for you. So molecular formula will be twice of that, as in C6H8 and nitrogen 2. I hope everybody is clear, because one of this question, C6H, somebody saying 12, Beta, it will be 2 times H8, I guess. Perfect, 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 perfect. Moving to the next one, guys. Few of the students were saying, sir, you will few of the students were saying, sir, you will not do concept. I am teaching the concepts also, coupling them with question, so that you are competent enough. This will be helping you to revise also, and those students who are not comfortable can attempt also. Because I have placed the next question, so what shall be your target for everybody? Whoever is facing basic problem, they can listen to me, but who other students who are here to revise, keep on attempting. Do not listen to whatever things, whatever generalized things I'm saying. You start attempting a question if you're here to revise. Yes, if you're here to be in sync because you're not comfortable with the concept, then you can listen to whatever the raita I'm in between I'm failing. But yes, the point that I'm making over here is, this is useful for every student attempting NEET examination, for practice also and for learning also. Chalo, moving forward. Moving forward, I need answer, guys. No reply? Answer, okay. We are getting answer. Chalo. 4. Perfect, perfect, beta. So the number of moles of hydrogen molecules required to produce by Haber process. So this is a question, this is a topic from stoichiometry. So here, I will, beta. So here we are dealing with stoichiometry. What is stoichiometry, sir? With respect to one species, what is the amount of another species produced? How to do that? First, you have to balance the reaction. So Haber's process is, if nitrogen and hydrogen reacts with each other, they form ammonia. First, balance the reaction. So twice will balance nitrogen, so this will be 1, and thrice will balance hydrogen. So I can say 1 mole of this can react with 3 moles of this to produce 2 moles of this. This is the stoichiometric coefficient. Question is saying number of moles of hydrogen. So number of moles of hydrogen we have to identify that can produce 20 moles of ammonia. So 2 moles of ammonia will require 3 moles of hydrogen. Always do it for 1. So 1 mole of ammonia will be produced when 3/2 moles of hydrogen will be reacted. How many moles of ammonia we need to produce? So 20. So how many moles of hydrogen will be required? So 30. Easy peasy. Everybody is done. But yes, these mole concept basic is very important for complete physical chemistry foundation, beta. Next question. When a certain amount of octane, formula is given, is burned completely, burned as in combustion of hydrocarbon. Combustion of hydrocarbon always produces the stable oxides, which are carbon oxide is CO2, hydrogen stable oxide is water. Now next job is to balance it. Because I have 8 carbon over here, so stoichiometry will be 8. Because I have 18 hydrogens over here, so stoichiometry will be 9. What about oxygen, sir? 16 plus 9. 16 plus 9 is, I guess, 25. So here I'll be having 25 upon 2, because I have a 2 in the oxygen. So ultimately 1 molecule of this or 1 mole of this react with this much of mole of this to produce this and this mole of CO2 and H2O. Now what shall we do? So question is asking us that I need 7.04 gram of CO2. So how many moles I need upon molecular mass? Molecular mass of CO2 is 44. So this is, let's say this value is N. Into divide is your piece of case, guys. But yes, you have to do it. So this is the number of moles of CO2 that I need. Now question is asking what is the mass of water formed simultaneously. So if 8 mole of CO2 is produced, then 9 mole of water will be produced. So if 1 mole of this is produced, then this much moles of water is produced. How many moles of CO2 is actually getting produced? Sir, N values here. So how many moles of water will be produced? Sir, this much. So this is moles of water produced. Now, do we need moles of water produced in the option? No, sir. We need weight. So weight of weight of water produced will be equal to moles of water produced into molecular mass of water, which is 18 gram. So ultimately my answer will be 9 upon 8 into 7.04 upon 44 into 18. So I hope be quick with your calculation, guys. So once you will solve, do we have some answer over here? Yeah. Nah, beta. Once you will solve, you will land somewhere around not 4, beta. No, you will land around 3.24. You have to be very religious with the calculation, guys. I hope everybody is clear. Let me see. Beta, you'll be getting somewhere around 3.24. You can approximate also. Good. Good. Guys, chalo. Moving to the next one. Now, few of the time the stoichiometry 4 is option. Okay, 3. Nahi beta, 3 is option. You just, Bhavna, you just check the calculations. I guess 3 is right. You may be doing something. Perfect. Chalo. Moving to the next one, guys. Attempt this one. You just have to calculate beta. I mean, yes, if at all you are thinking, no, sir, I have done correctly, though maybe I would be having some option error, but I don't feel it will be. Chalo. Moving to the next one. Come on. Fast. Quick. Atharv, Rowan, Bhavna, Jyoti. Quick. Chalo. Quick. Now, this question is using, after stoichiometry, it is coupled with a logic of percentage or purity. Now, how to do it, sir? Right option for the mass of CO2 produced by heating this much gram of 20% pure. So, the reactant that you're using is not pure. It is only 20% pure. So, do complete 20 gram will react? No, sir. What will be the pure species at 20%? So 20% of 20 gram will be 20 into 0.2. 20 into 0.2 is 4 grams. So actually 4 gram will be your actual weight that will be reacting. This is just a simple mathematics of this limestone. So what is limestone, sir? Okay, reaction is also given. So calcium carbonate is limestone. It reacts and produces CO2. So sir, 1 mole will produce 1. So what is the actual number of moles getting reacted? Number of moles of calcium carbonate actually is, what is the actual weight? 4 gram upon molecular mass is 100 grams. So this is the actual moles. So let's say this value is n. So 1 produces 1. So n will produce n. So this is moles of CO2 produced also, but we are supposed to calculate weight of CO2 produced. And weight of CO2 produced will be 4 by 100 into 44. So you just have to do that base simple into divide again. So I need answer quick, guys. Perfect. So a very simple, but yes, a very effective and a very probable question for your NEET examination. Many of these questions are direct PYQs only, beta. The reason I have not written it, because you will also be going in the examination with different mathematical parameters. The concepts are, the concepts will remain the same. Moving to the next one. Quick. Be super quick. By the time I poured some coffee for myself. Chalo, my coffee is also finished. Answer, guys. Answer. So the question is telling us, yeah, I guess you're right. The question is telling us that 20 gram of calcium carbonate sample decomposes on heating to give carbon dioxide and 8 gram magnesium oxide. So let us write the basic reaction. Magnesium carbonate is this. On thermal decomposition, it is giving you carbon dioxide and magnesium oxide. So magnesium oxide is MgO and oxide is CO. Carbon dioxide is CO2. So I hope the reaction is balanced only. So stoichiometry is just 1. 20 gram of magnesium carbonate. So 20 upon molecular mass. Molecular mass will be magnesium is 24 plus carbon is 12 plus oxygen 16 into 3 is 48. So this will be the number of moles of magnesium carbonate. Give and 8 gram of magnesium oxide. So magnesium oxide I'm getting is actually 8 gram. So 8 upon what is the number of moles? Sir, magnesium is 24 plus oxygen is 16. So this much moles of magnesium oxide I'm getting, and this much moles of magnesium carbonate is getting decomposed. Now, what will be the percentage purity of magnesium carbonate in the sample? Now we have to calculate the purity of this sample. That means if at all, let us consider this is 100% pure. So 100%, if it will be 100% pure, then whatever we are doing theoretically, we should get that much. But question is not giving us that. Question is actually giving us what is the moles produced. What is the moles produced? 8 gram. So the number of moles that we have calculated will be the actual mole produced, and here I will be getting the theoretical moles produced. So can you tell me first, according to stoichiometry, what will be the theoretical moles produced? So 1 produces 1, so n will produce n. So n moles should be produced theoretically. And what is actual mole produced, sir? Actual mole produced will be given weight upon magnesium oxide molecular masses 24 plus 16. So this much moles will be the actual moles, and this much moles is the theoretical mole. If efficiency is 100%, this will be equal to this. Or else, in order to calculate efficiency, I will calculate actually what is produced and theoretically what should be produced into 100. I hope everybody is clear. यकीन ड्रॉपर हिंदी मीडियम बैच कब स्टार्ट होगा? सून इनफ बेटा. सर विच कॉफी पाउडर यू यूज? Beta, good one. Chalo, moving to the next one. Okay, what is the answer, guys? What is the answer? Yeah, calculation you have to do, and once you'll solve, yeah, perfect, perfect. Eskin is also giving answer to. Robin is also giving answer to. Perfect, guys. You guys are supercharged. Perfect. Next question. Perfect. Perfect, Rowan. Answer. Chalo. Chalo, chalo, chalo. Next. Find the number of molecules of C formed when 20 mole of A react with excess of B as per reaction. Now this is my reaction, and question is telling me that 20 number of moles of C formed. You have to determine number of moles of C formed when 20 mole of A is reacted. So 20 mole of A is, sir, 2 will produce 3. So 1 will produce 3 by 2. So 20 will produce into 20 as in 30 moles. So this is, I mean, you do not even have to move your pen for such questions. I hope everybody is clear with this. Hey? It is saying option 2. Let us check it again. Number of moles of C formed when 20 moles of A react with excess of B. Okay, efficiency is 80%. I'm sorry, efficiency is 80%. So read the complete question. I have read this question till here. Don't do this in your NEET examination. So what was the moles? So 30 moles will be produced when efficiency is 100%. As of now, efficiency is 80%. So 80% of 30. So 8 3s are 24. So this will be your number of moles. Option 2. Perfect, guys. Perfect. 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 Moving to the next one. Moving to the next one. Next question says, yeah, perfect. Moving to the next one. I am enjoying this because you people are enjoying it. You are very, very comfortable. You are very, very active in giving answers. So I know that you are there with your pen and copy. Perfect. Next question says, when 5 mole of N2 react with 10 mole of hydrogen, the mole of ammonia. Now this is a question when both the reactants are given. This becomes a question for limiting reagent. So this becomes a concept for limiting reagents. So what shall we do for such things? Sir, just common sense. What is the common sense? Let me decode it. Nitrogen reacts with hydrogen to produce ammonia. We have already balanced this reaction. Sir, this is 2, this is 1, and this is 3. What are the moles given? Number of moles of nitrogen given is 5. Number of moles of hydrogen given is 10. Sometimes these moles will not be given, so you have to calculate number of moles. Now, how to check stoichiometry? The coefficient will help you. Sir, 1 requires 3. So 1 requires 3. So 5 will require 15. Do I have 15? No. That means this is my limiting reagent, and product is always decided as per limiting reagent, as in I will use the stoichiometry of limiting reagent to identify the product. As in I will say that 3 moles will produce 2 moles. So 1 mole will produce 2 by 3 mole of product. And how many moles of hydrogen is actually getting reacted? 10. So how much moles of ammonia will be produced? So 20 by 3. 20 by 3 is where? 20 by 3 is option 3. Perfect, guys. Perfect. Moving to the next one. Answer, guys. Let us try to check the poll again. So let me give you 30 seconds. Let me see. Maybe I can get that poll. Now at least maybe can get that poll. Chalo, I need answer, guys. For previous question it is good. Yeah, I need answer for this one. Do have J mains question, sir? Nahi beta. I have specifically taken all the NEET relevant questions. Why J? You people are going to give your NEET examination. Chalo. So answer is option A. No, my poll is still not working. I wanted this to work. Chalo, moving to the next one. The next question says 12 moles of each A and B are allowed to react as per this reaction. Now 12 moles of A and B. So this is also 12 moles. This is also 12 moles. So first we have to identify which is limiting reagent. Sir, 3 requires 2. So 3 requires 2. So I mean 2. Sir, both have different. So the one which is required more, as in let us do for B only. 2 requires 3. So 1 will require 3 by 2. So 12 will require into 12. So this is 6 into 3, 18. So 18 is required. But how much of A I'm having? 12. So obviously who will become my limiting reagent? A. You can obviously without doing this also can predict, because 2 requires 3. So A required is more. But given A is less, so obviously that will become my limiting reagent. So the product will be produced as per limiting reagent. And what are we asked? If 60 gram of D is produced, then calculate atomic mass. Now it is also giving you how much of D is produced. So I know limiting reagent is A. So 3 will produce half of D. So 1 mole of A will produce 1 by, so let me do that stoichiometry for you. 3 moles of A will produce half mole of D. So 1 mole of A will produce 1 by 6 moles of D. How much moles of A? I am reacting 12. So this will produce 12 by 6, as in 2 moles of D. So how much moles of D are produced? 2. 2 moles are having a weight of 60 gram. So 2 moles weigh 60 grams. So 1 mole will weigh 30 gram, and that mass of 1 mole is molar mass. So molar mass will be clearly 30 gram. Yeah, perfect. I think we have type alphabetic option, so the poll will work. Maybe. Okay, beta. I mean, yes, it may work, it may not work. These are all technologies which, yes, sometimes helps us, but because we are so much active in the chat only, so why bother? We will not do poll. Chalo, moving to the next one, guys. The next question says, Answer? Answer, guys. Sir, can you please provide top questions for NEET as you did for J beta? Bhavan, that Bhavna, that is all what I'm doing. I have, I mean, me along with my DTP, we have worked till I guess 1:32 in the night just to segregate all the relevant questions for you. So don't worry, whatever the questions and concepts I'm repeating now, they are exactly your NEET PYQs. The only thing I've done is like in my J channel, what we used to do is we used to give the year also, because for J we have a lot of bunch of questions, because each year we have 20 papers, not even 20, 40 papers, because 5 days, two paper each day, so 10 paper, 40, 10 paper on January and 10 paper on 20 papers, so 20 papers per year. So in a span of like 4 5 years where JE has become online, we have got so much bunch of questions, so therefore we do not require any other PYQ to attempt. But for you NEET guys, you just have one paper, so the number of PYQs is limited for you. So what we have done is we have specially curated those PYQs. Yes, my team has also helped me a lot. So chalo, moving forward. Chalo, moving forward. Now the question says 1 gram magnesium is burnt with this much gram of oxygen in a closed vessel. Okay, sir. Which reactant is left in excess and how much? So I hope this is the same question. Robin is also saying, Dharam is also saying. So let me, everybody is correct. So you again have to do that stoichiometry. है ना? Chalo, perfect. Robin is also right. Bhavna is also right. Move, because we have to do the same thing. So for practice also, that for those students who have not attempted it properly, that will be a homework for you. So attempt that question, because mathematics you can only do once you practice hard. Chalo, perfect everybody. Answer for this one. Now from this we are moving to concentration terms. That means we are moving to solution and colligative property side of chemistry. Chalo, है ना? So from here we are moving to concentration terms of solution. From this we are moving to concentration terms of solution. Chalo. So the question says, answer, very good. Subhash, perfect. Robin, perfect. Now, which of the following in ppm, what is concentration in ppm if this much gram of KCl is dissolved in this much gram of water? Sir, what is the formula of parts per million? Parts per million by weight. So weight by weight ppm is equal to weight of solute. Now, whenever I will be writing concentration terms formula, I will designate 2 for solute, 1 for solvent, because that will make our formulation of formula very easy. And whenever I am having solution, I'll be writing solution only. So what is formula for parts per million by weight? Weight of solute upon weight of solution into 100 will give me percentage, into 10 raised to the power 6 will give me parts per million, into 10 raised to the power 9 will give me parts per billion. So because we have to calculate parts per million, that as in this. So weight of solute is how much? So 0.025 gram. Weight of solution will be 100 plus 0.025. Why bother, sir? You can check mathematically also that it is nothing but it is 100. So definitely, because this is very dilute, so here it will be weight of solvent. Not everywhere, but here. Why here? Because solute is very negligible. So while doing mathematics also, you can judge that you will not be bothered that this is 0.25. So in denominator you will simply approximate to 100, and once you do that, I guess you will land at 250 ppm. Calculation is also very easy. Yeah, everybody is correct. Moving to the next one, guys. Next question. Attempt coming in 40 minutes. Okay. Subhashri, But beta, around 1 we'll be taking a bio break, है ना? Because till that time we'll be finishing the half of the, because I have broken my max hub gets hanged if I take more than 100 pages in a PPT. So I've taken half, so halfway 25 50 questions I have, 52 questions I have with the first half, and we'll take a bio break for 10 minutes around 1 p.m. Then we'll again meeting for the later half of the questions. Chalo. So we are in the concentration terms calculation. So the question is, you have to calculate 3.42 gram of a substance of molecular weight this much is present in this much of water. You have to calculate molality as in small m. What is definition of molality? Sir, weight of solute upon molar mass of solute. This will give you number of moles of solute into weight of solvent, but this should be placed in kg. So if I am placing this weight in gram, so I have to introduce 1,000 in the numerator. So this much gram of substance of molecular weight, so the weight of solute is given out to be 3.42. Its molar mass is given out to be 342. The calculation is also very easy, in 2000, and weight of solvent, which is water, is this much. So I hope this is very easy also to attempt. Everybody has got the answer. Moving to the next one. Perfect, perfect. Perfect, Dharma. Perfect. Moving to the next one. Mole fraction of solvent in aqueous solution of NaOH having molality 0. Having molality 3. Okay. So here molality is given and you are asked mole fraction of solvent. So quick attempt. Attempt, guys. Attempt. Now, obviously we know some formula also. For a NEET level of examination, I suggest you should rather remember that formula also, but yes, you can do by basics also. So for this question I'll be doing it by basic also, and I'll be doing by option by formula also. Yeah, perfect, Robin. Perfect. Answer is 4. Perfect. Let me give you the formula. So molality can also be calculated as x2 into 1000 upon x1 m1, as in this is mole fraction of solute and this is mole fraction in molar mass of solvent. You can either use this formula. If you use it, just put the value and solve, or else, sir, my name is Dharmayu. Okay, Dharmayu, good. So beta, you can either use this formula, but sir, some of the students will feel, sir, can you share the formula? Beta, I've written the formula for you, but yes, most of the students forget this formula, and if at all you are forgetting that formula and not attempting the question, so rather spend a few minutes and then attempt the question. So for those students who find it difficult to remember the formula, let me give you a common sense also. So molality is given, so always kill variables. How to kill variable? What is definition of molality? Molality is equal to number of moles of solute upon weight of solvent in kg. The molality is given out to be 3. Just kill a variable. Consider a solution, because every solution, whatever amount you take, the concentration, the sweetness remains the same. So we can take any amount, but then we do all calculation for the fixed amount. Let's say this weight I am fixing as 1, so denominator is killed, but I will be now working for 1 kg of solvent. So solvent is 1 kg. So if I have the solution, I don't know anything about solute and other things, but yes, because I fixed weight of solvent, here weight of solvent is 1000 gram. Now I'll calculate everything for this solution. So here this denominator, and if this is 1, then definitely N2 is, so number of moles of solute I also know, here it is 3. What are we supposed to calculate for this question? For mole fraction of let us calculate mole fraction of solute first. So mole fraction of solute will be number of moles of solute upon total moles. Number of moles of solute I already know in this particular solution. So it will be, now the only thing I require is number of moles of solvent. So number of moles of solvent will be weight of solvent upon molecular mass of solvent. Solvent is water, so it is 18. So this is 55.55. So you can directly calculate by this. But sir, question is asking mole fraction of solvent. So mole fraction of solvent will be 1 minus mole fraction of solute. So this is the common sense by which you can do it, and this is the direct formula by which you can do it. So whatever pleases you, you can proceed accordingly. Moving to the next one. Attempt, guys. भाई देख, पहले तेरी okay, Dharmayu, good. चलो, moving to the next one. हाँ, चलो बेटा, good one. Moving to the next one. The next question says density in gram per ml or gram per cc of this much molar. So this is molarity. This is percentage mass by mass will be the density of this much molar. Okay, and you have to determine density. Okay, the English was tricking us. So yes, for such questions also you can do by basics also. The basic I have already given you an idea, but yes, for a NEET level of examination it is always advisable to learn these are very important conclusions. So molarity can be calculated as percentage weight by weight into density of solution in gram per ml. The question is asking in gram per ml only, into 10 upon molecular mass of solute. Molarity is given, it is 3.6. Percentage of mass by mass is given, it is 29. Density we have to calculate into 10 upon what is solute. Solute is sulfuric acid, so molecular mass is 98. If you just solve this, let me, guys, be quick with the calculation. So if you calculate it correctly, you will get somewhere around, yeah, perfect. Perfect, Robin. Perfect. Robin is calculating with huge accuracy. Good beta. Moving to the next one. The next question says aqueous solution of solute X, which has molar mass this, has density this, if the molality is this. So again, you can do by basic also, the one you kill the variable thing, or else you should definitely know some results also. So how these things are related? So density of a solution is equal to capital M as in molarity 1 upon small m plus molecular mass of solute upon 1000. So this is a very important relationship. You will definitely land up a question with this, and one variable will be hidden. So for such a question, they are asking molecular mass of solute X. So okay, the molarity you have to calculate. Density is given out to be 0.98. Molarity we have to calculate. Molality given out to be 3. Solute has molar mass 60 upon 1000. So this is now just, yeah, I mean, yes, calculation will require time beta, but that you can only master with practice. So once you solve, you will be landing up with option 2, not option 1, guys. Most of them are saying option 1. You will be getting 2.49. Yeah, perfect. Robin, good one. Next one. Next one. Now, with such questions, we are coming with the logic of which of the following statement is true for Henry's law. We are moving more into diving deeper into the concentration terms of solution. Now, concentration of terms of the solution is first part of the chapter of solution in colligative property and last part of chapter of mole concept. But because we have almost completed mole concept, so let us deal with the other part of chapter solution. So chapter solution says that whatever liquid solutions we have around us, JEE, NTA and NEET also frame questions around liquid solutions. What are liquid solution? When solvent is liquid, solute can be solid also, solute can be liquid also, and solute can be gas also. When solute is gas, solubility of gas in a liquid is determined by Henry's law. Henry's law says that amount of gas, whatever concentration term you can use, Henry law says that amount of gas that can be dissolved in a solvent is directly proportional to partial pressure of that gas over the solution. This is nothing but Henry's law. And once you use concentration term of mole fraction, then you get the proportionality constant, which is also called Henry's law constant. So such theoretical questions can also be there in your examination. So this Henry law deals with solubility of gas and liquid, therefore definitely option 2 is correct. But yes, you should know certain points. Acha, side please. Beta, I've given you side. I'm sorry. Okay. Now, but yes, you should know certain points. Henry's law is applicable not always. When it gets offended and is not followed, very important beta, whenever you have very high partial pressure, Henry law becomes inapplicable. Whenever temperature is too low, the kinetic energy of the gases becomes, they practically cease, and therefore Henry law again becomes ineffective. And whatever gas we take in that solution, they should not chemically react. So if these three conditions are valid, then do not apply the formula of Henry's law. But yes, JEE frames question around it also, good questions. But for NEET level of examination, you should at least know the theoretical points that when it is not applicable. Moving to the application of Henry law, very important NCERT logic. First application of Henry's law is a disease called, not actually a disease, a phenomena called anoxia. Whenever you go to high altitude, so partial pressure of oxygen decreases because you have came out of the atmosphere. I mean, you have came top of the atmosphere, so some of the gases have been uh, on the lower altitude. So because you are at higher altitude, so pressure of oxygen is less, so the oxygen that will be dissolving in your hemoglobin blood will also become less. So because of lesser supply of oxygen to your blood vessels, you have a you start drowning, and that that phenomena, you are bio guys, so you know it much better. It is called anoxia. And another thing is bends. When you scuba dive, deep sea dive, then pressure now increases, and the pressure of gas, what gas is there in atmosphere in a larger percentage? Nitrogen. So when nitrogen gas gets dissolved in your bloods, those bubbles of nitrogen also create a serious phenomena, and that serious phenomena is called bends. How to avoid it? So the air tank that we take to breathe in inside the water during the scuba dive is diluted with other gas. It do not have just air, it is diluted with helium. What is the percentage? It is also very famous percentage, that composition, the complete composition you should learn. It is diluted with 11.7% helium, 56.2% nitrogen, and 32.1% oxygen. So this composition also is very, very famous NCERT fact. I hope you are getting it. You will be getting this notes, don't worry. Yes, after my class, go to PW NEET English WhatsApp channel, and all these lecture notes will be posted over there for free. So if you need these questions to see again or to practice, you can obviously download it from PW NEET English WhatsApp channel. Chalo. Moving to the next one. See, the same questions they are asking because these are very famous NCERT facts. Moving to the next one. Now, the solubility of nitrogen in water at this temperature and this pressure is this much. Okay, the solubility is given in gram per liter. What is gram per liter concentration term? It is called strength. What is strength of a solution? Amount, weight of solute dissolved in 1 liter of solution. So yes, any concentration term they can use. So right now they are using the strength of solution. The solubility in gram per ml only, but when partial pressure is increasing. So the partial pressure is increasing, you have already told us partial pressure is directly proportional to amount, and this amount can be taken in any concentration term. Right now they are taking what concentration term? Strength of solution. So partial pressure at state 1 upon partial pressure of gas at state 2 will be equal to strength at state 1 upon strength at state 2. The partial pressure initially is 500. Afterwards, it is increased to 750. Initially, strength was 0.01, and you can easily calculate strength after that. So this is an into divide now. Answer, guys. I hope once you solve this, yeah. Dharmayu is perfect. Robin is perfect. Chalo, moving to the next one. Moving to the next one. Quick, quick. Question says the correct option for value of vapor pressure. Now we have came to liquid and liquid solution. So again we are discussing liquid solution, but liquid in liquid solutions. So liquid in liquid solutions are dealt by combination of Dalton's and Raoult's law. What does this combination tell you? This combination tell you, Dalton's law tell you that total pressure as in pressure of solution is equal to partial pressure of both the components. Let's say partial pressure of A and partial pressure of B. This is what we know through Dalton's law. But Raoult tell us that partial pressure of each component is directly proportional to mole fraction of that component in the liquid phase. So combining Raoult and Dalton law, we get pressure of total or pressure of solution is equal to P naught A XA, where P naught A is the partial pressure of pure component A, XA is its mole fraction in the liquid phase, plus P naught B into XB. Now, I guess here, let's say benzene we consider as component A and octane we consider as component B. So this 280 will become P naught A, this 420 will become P naught B. So I have P naught A and P naught B. What else I need? I just need value of XA and XB. So they are giving you their ratio. Their ratio is 3:2. That means you can take that mole ratio also. So what will be XA? Sir, I have 3 parts of A, and what will be the total part? 3 plus 2. That means 5. So if XA is this, XB will be 2 by 5. So I know XA also, XB also, P naught A also, P naught B also. Once you put this, you will get the, mathematics is required. Didn't get question, sir. Okay, Dharmayu, I'm repeating the question again for you. The question says the correct option for the value of vapor pressure of a solution. Vapor pressure of solution is total pressure. At this much temperature of benzene to octane in molar ratio. Now the components, the liquids that you are mixing is benzene and octane. They will form an ideal solution because benzene and octane more or less are hydrocarbons, and if the species those are hydrocarbons, they are mixed, then generally they form an ideal solution. Although practically there is no solution called ideal solution because you obviously have some positive and negative deviation, but yes, because the question is asking, so the general trend is telling you that it is an ideal solution. Because they are giving you the molar ratio as in their moles ratio, so you can calculate their mole fraction. 3 parts of A and 2 parts of B, so total will become 3 plus 2. So mole fraction of A will be 3 upon 5, mole fraction of B will be 2 upon 5. Just put the value of X and XB. P naught as in their vapor pressure in pure state is given in the question as 280 and 420. Just put them and you will get your answer. I hope Dharmayu, you get the theory right. Moving to the next one, guys. Now, this question is also beautiful. Just try and attempt it, guys. A very basic logic. Try and attempt, guys. Come on, come on. Okay, my coffee is finished, so let me drink some water. We'll take a bio break. Then I'll get my coffee refilled. Chalo. Moving to the next one, guys. The next question says, at a given temperature, total vapor pressure in torr, this should be small t, of a mixture of volatile component is this. Okay. Sir, you have to calculate vapor pressure of pure component A and B. So with that Dalton and Raoult law conclusion, you can obviously see, sir, if XB is 1, then XA will be 0. Why? Sir, because mole fraction of two components, summation is always 1. And if xb is 1, that means you have only b in your solution. So this total pressure will become P naught B. This total pressure will come P naught B. So just put XB1. What are you going to get? So we are going to get 120 minus 75. That means 120 is 5. 11 minus 7 is 4. I guess this is 45, right? 25 or 20, 45, yes. So this is 45, this is P naught B. And sir, what about P naught A? Sir, when XB is 0, then XA will become 1. In this case, what will be the total pressure? It will be just due to A, because in the solution you only have A. That means the pressure is partial pressure of A only, the pure component. So putting XB 0, I'm getting P naught A directly as 120. So an easy peasy question, but yes, a very probable question for your NEET examination. Moving to the next one. Everything is easy once you know it, and everything is a dilemma if you're confused. That's why we are here, getting all those logics cleared. Moving forward. Chalo. So let us answer this one, guys. Perfect. Option 3, Amin is saying. Okay, let us attempt this one also. The question says vapor pressure of pure benzene and toluene are this and this. Now this is again the same question. This is P naught A, this is P naught B. Let's say benzene is A, toluene is B. The mole fraction of toluene in vapor phase. Okay, vapor phase. Now what is this vapor phase? Sir, chi A or XA is the mole fraction represented in liquid state. Whenever these liquid solution forms a vapor, some of the components will be present in vapor phase also. That's why they are creating pressure. Those liquid solution creating vapor pressure. So molecules will be there in the vapor phase also. We represent that vapor phase as the mole fraction in vapor phase as YA. So if I am having the solution mixed with component A and component B, so we will be having some components in the vapor phase also. I hope everybody is clear with this. Now we have a mole fraction XA and XB in the liquid component. In the vapor phase, we represent them as YA and YB. So what will be YA? You can use your common sense for Dalton's law and Raoult's law. Raoult law says that partial pressure of A is equal to P naught A into XA. But Dalton's law says that partial pressure of A in the vapor phase will be mole fraction of A in the vapor phase into total pressure. So if we divide that with total pressure, we will get our mole fraction in vapor phase. Similarly, for YB, it will be equal to P naught B into XB upon total. And total pressure you can calculate as we have written the formula P naught A XA plus P naught B XB. So here in this question, P naught A, P naught B is given. Mole fraction of toluene in vapor phase. So toluene is my B. So we have to calculate YB with equimolar solution of now. Equimolar solution as in molarity, as a number of moles in the liquid phase is equal. So if number of moles is equal, that means we are given this XA and XB is 1 by 2. So XA, XB is given. You can calculate P total. And once you calculate P total, put values over here. Let me do it for you. So YB is equal to P naught B, which is 60, into XB, which is half upon P total. So P total will be 160 into half plus P naught B is 60 into its mole fraction half. So you just have to calculate. I guess few of you have calculated this also. Yes. Once you will be solving, I guess you will be landing somewhere around option 3. Didn't get question, sir. Dharmayu, I hope you get the question now. Acha, that was your previous comment. I hope everybody is clear. Guys. Chalo, moving to the next one. Now, in my next slide, I am trying to make you revise one more thing. Okay, perfect, perfect, Dharmayu. Now, we have non-ideal solutions also, because practically, if you mix two solutions, both of them will not have same intermolecular attractions. Rather, they will attract each other more, then they form a non-ideal solution showing negative deviation, or else they will move away from each other. That means they will form solutions which show non-ideal solution which show positive deviation from Raoult's law. Now, I'm not talking practically, because practically no solution is ideal solution. But yes, for your NEET level of examination, whenever you have a solution of same family, for example, chlorobenzene, bromobenzene, same family, aryl halides, heptane, hexane, same family, hydrocarbons. So they form ideal solution. You just need to know non-ideal solution showing negative deviation from Raoult's law, because they have some special attraction force, and that special attraction force is always a plus minus attraction. I'm repeating again, beta. I'm repeating again. Scroll. I'm repeating again, beta. This definition you want me to repeat now? I'm again repeating. What I'm saying is, whenever you have solution mixed by components that belong to same family, they are called ideal solution. Correct? Okay. Whenever you actually mix two components which find some attraction, what is that special attraction? That special attraction is always hydrogen bonding. Hydrogen bonding, or some special plus is attracting some special minus, which is always a case of logical hydrogen bonding. So that hydrogen bonding will allow the two components to mix, and when those two components mix, so they will get attracted. So at the same temperature they are getting more attracted, so they will make less vapors, and therefore they show negative deviation from Raoult's law. All the solution which shows negative deviation from Raoult's law, in order to boil them again, you have to apply more temperature. Therefore, they generally then boil at an elevated temperature. Best example of negative deviation non-ideal solutions you should learn, and these are some examples which will make all of your questions correct, like chloroform and acetone. Now let me just make an example. What is chloroform? Sir, this is CHCl3. Because chlorine is attached with so many electronegative chlorine, therefore carbon, therefore this carbon will also become electronegative, and because it is withdrawing electrons, so it will create a very nice, very high magnitude of partial positive charge in hydrogen. And once this hydrogen, which is not connected with oxygen, hydrogen, with fluorine, oxygen and nitrogen, these phone, you can remember these elements by the mnemonic phone. So these phone, when attached with hydrogen, creates very high positivity. That therefore they are supposed to produce hydrogen bonding. But this carbon, because it is attached with 3 chlorine, also becomes electronegative and creates a high magnitude of positive charge in hydrogen. Whenever this sees acetone being a polar molecule having oxygen, so this minus plus will attract each other, and this is special bond called hydrogen bond. Because hydrogen bonding is nothing but whenever the magnitude of charges increases, so dipole attraction becomes very, very strong. So this strong dipole attraction makes them a negative, make them closer to each other, and therefore they show negative deviation from Raoult's law. So famous example are this: chloroform and benzene, chloroform and diethyl ether, water and HCl, water and acids always form non-ideal solutions, strong acids. Acetone and aniline, phenol and aniline, water and nitric acid. This is also a famous example for azeotropic mixture, 68% nitric acid. And pyridine and acetic acid. These are some very useful examples which will cover whole of your questions. If you know them, they show negative deviation. If they are of same family, they'll be ideal. Else everybody will be positively deviated from Raoult's law. I hope it is good. Chalo. Scroll, sir, why the uses of chloroform is stopped or banned? Because beta, government don't want you to because actually chloroform creates phosgene. Phosgene is poisonous, and because of that, you must have seen those Bollywood films that whenever you wish to kidnap the heroine, the villain used to take that to chloroform. So obviously, because of those reasons, it is not advisable, and therefore it is banned. So Focus on the relevant questions, beta. Chalo. The phone was more radiation of the reaction towards the compound is more. हाँ बेटा चलो. चलो बेटा. Moving to eh? चलो ओके 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 चलो चोरी. Next question बेटा. Next question. The deviation that we have spoken, now we have a theoretical question for that. Total vapor pressure of a mixture of 1 mole of A and 2 mole of B is this much. So what shall it will show? So first we do the Raoult law calculation. So according to Raoult law, total pressure should be P naught A, which is 150, into mole fraction of A will be, I have 1 mole of A and total I have 3 moles, plus what shall be partial pressure of B, P naught B, into its mole fraction will be 2 by 3. So this is nothing but 150 by 3. So 150 plus 480 by 3. So this is 0, 8 plus 5 is 13, and this is, so this is 210. So this is 2, how much, what is the unit? Torr. So as per Raoult's law, total pressure should be, as per Raoult's law, total pressure should be 210. But actually, how much total pressure we are getting? 200. That means it is less than the calculated value. So because this partial pressure, the total pressure of the solution is less than as per calculated by Raoult's law, so it is showing a negative deviation from Raoult's law. So it is showing a negative deviation from Raoult's law. I hope everybody is good. Yes, Annalene. Aneme inspector. It is definitely an aesthetic. Yeah. You are talking of chloroform. I guess that okay. Now this, you are bio student, so I guess that was not a spam. That was actually a question. Chalo, moving to the next one. Yes. So actually, chloroform with oxygen gets oxidized, forms phosgene, which is poisonous. And as Aneem is saying, it is used as an anesthetic, as in if consumed in a doctored and quantified amount, that it can be used as an anesthetic. But yes, if consumed in a larger amount, then it can definitely result into some serious issues. Now, the next question is, let us attempt this one. I hope this is also very much doable, but yes, a good question where you should invest time in reading out the question properly. Yeah, perfect. Rowan is right. 100 ml of liquid A and 25 ml is mixed to give a solution which does not obey Raoult law. Okay. The volume of the solution. Sir, I am mixing 100 ml of this and 25 ml of this. So it should form 125 ml ideally. But it is saying it do not follow. So it will not be equal to 125. It can either be more, it can either be less. When it is more, when it is showing positive deviation. When it will be less, when it is showing negative deviation. So it can either be more or less. So option 2. Yeah, perfect everybody, perfect. Moving to the next one. An azeotropic solution of two liquids has boiling point lower than either. Sir, what are azeotropic mixture? Azeotropic mixture are those non-ideal solutions which show large deviation from Raoult's law. If I show large positive deviation from Raoult's law, if I show large positive deviation from Raoult's law, that means I am going in the vapor phase more and more. So those large deviation non-ideal solution can boil even at a lower boiling point, and at a particular composition, they behave like one solvent, because after that mole fraction in liquid phase and vapor phase for those non-ideal solutions remains the same, and such solutions, such non-ideal solution at that particular composition are called azeotropic mixture. How many types of azeotropic mixture we have? Two. Those who show positive deviation from Raoult's law forms minimum boiling azeotrope, as in their boiling point is minimum than the individual boiling points. And those who show large negative deviation from Raoult's law, they form maximum boiling azeotrope, as in order to boil them, the constant boiling point is even higher than the boiling point of the individual components. I hope everybody is clear with this. Now, the question is saying that an azeotropic of two liquid has boiling point lower. So because it is having lower boiling point, so it must be showing positive deviation from Raoult's law. So it must be showing positive deviation from Raoult's law. I hope everybody is clear with this. Scroll is asking, sir, what is characteristic property of a maximum? Beta, maximum boiling azeotropes, the famous example of those maximum boiling azeotrope is the NCRT famous example of water and ethanol. So their basic characteristic is whenever they are formed at a particular composition, that their mole fraction both in liquid phase and in vapor phase, they become equal and they start to behave as one solvent, because both of them are boiling at a constant boiling point, and that constant boiling point will be, in case of water and ethanol, that constant boiling point will be even lesser than the boiling point of individual components. What is the percentage composition where water and ethanol form that as isotropic mixture? Generally it is 95%. 95% of water and approximately 5% of ethanol. I guess other way around, 95%, 95% solution. That means 95% ethanol and remaining percent of water. है ना? चलो, moving to the next one, guys. Now, water and perchloric acid. Now, ethanol was an organic compound, but if I have a mineral acid, then water and all the mineral acids, they form non-ideal solution showing negative deviation from Raoult's law. They form non-ideal solution showing negative deviation from Raoult's law. So water and HNO3 being the most famous example, where 68% HNO3 forms a azeotropic mixture with the remaining percent of water. Now, they form constant boiling mixture at this much, sir, because it is negative deviation, so this boiling point will be maximum. Now, it is giving you a percentage also. For ethanol, it is 68%. For perchloric acid, this is the composition is 71%. The boiling point of the solution at this component will obviously be greater. What is boiling point of water? 373. What is boiling point of perchloric acid? 383. So the boiling point of the azeotropic mixture will be greater than even water and perchloric acid. So it will be option more than 383. So option 3 will be your right answer. I hope everybody is clear with this also. Perfect. Perfect, Sonam. Perfect, Dharam. Everybody is right. Moving to the next one, guys. Quick. Now, vapor pressure of a solution containing 4 gram of non-electrolyte in 90 gram water at a particular temperature is this much. So this is vapor pressure of solution. The vapor pressure of pure water is this much. The molecular weight of the solute. So this is a question from the first colligative property, which is relative lowering of vapor pressure. What is the relative lowering of vapor pressure? Sir, it is P naught minus PS upon P naught. And what is it equal to? It is equal to mole fraction of solute. Mole fraction of solute is, it is equal to number of moles of solute upon number of moles of solute plus number of moles of solvent. Now, because generally colligative properties are only valid for dilute solutions. What is a dilute solution? When number of solute is very less in comparison to number of moles of solvent. So practically for dilute solutions, so this is first thing, which is, this is called relative lowering of vapor pressure. So for dilute solution, this is the second point that I'm making. For dilute solutions, number of moles of solute is very, very less than solvent. So actually N2 plus N1 is approximately nothing but N1. You can use this also, but sometimes even I'm telling you, whenever calculations are very precise, whenever options are very close, then ultimately after writing this as N1, still you are approximating. So if you take the ratio of P naught minus PS upon PS, it will be exactly equal to N2 upon N1. You can rearrange and check that. Else, you can also do P naught minus PS upon P naught. Now, this will actually be equal to RLVP. This is not RLVP. This is RLVP. It is approximately equal to N2 upon N1. Because ultimately you are saying solute is negligible, but ultimately you are approximating. And whenever the questions are options are very close enough. So this is the exact formula. This is the exact formula which you can reuse. But yes, this is a approximated formula. Now you can, for a question where you have large answer difference, you can use that approximate formula also. So here they are giving you, this is pressure of solution, this is pressure of pure solvent. So P naught minus PS will be 3000 minus 2985 upon P naught, as in 3000. It is equal to, approximately I can do N2 upon N1. So N2 is weight of solute is 5 gram. Molar mass of solute I have to calculate. Weight of solvent is 90 gram and molar mass of solvent is 18. So you can clearly solve, and once you will solve, your answer will be, I mean, this is easy to calculate also. It will be 200. Now into divide is your piece of job, guys. I hope everybody can do that. I hope everybody can do that, guys. Chalo, moving to the next one. Now, moving to the other colligative property. So after relative lowering of vapor pressure, we can move to elevation and depression in boiling point and depression in freezing point. Whenever I add a non-volatile solid solute, the vapor pressure get reduced, therefore the relative lowering. If I want to boil you again, then I have to increase your vapor pressure. I have to make it equal to atmospheric pressure. So that increases the boiling point. Now, if I want to freeze it, I will take out heat, but the solid will also be giving out heat, but it is a solid, so it will remain a solid, but I have to remove heat from that solid also. So therefore, I have to bring the temperature down. So boiling point is increased and freezing point is depressed. I hope everybody understand that. Now, the formula for elevation in boiling point, which is delta TB, which is nothing but boiling point of solution minus boiling point of pure solvent. It is equal to Van 't Hoff correction factor as an I times of mole ebuloscopic constant, as in the proportionality constant, which is ebuloscopic constant as in molar elevation constant for solvent, into molality. Now, because the question is saying that to observe an elevation and boiling point of this much, so it is giving me value of delta TB, which is 0.05. Do not bother about degree Celsius, because change is always in Kelvin. Also change will be this much, and degree Celsius also change will be this much. So delta TB is given. The amount of solute to be added in 100 gram, KB is given. Because the question is giving no information about I, how you calculate I, we'll be seeing in other questions, but I'm discussing over here. I is generally calculated for, if the solute is dissociating, it will be 1 plus n minus 1 into alpha. What is n? Number of ions formed by the salt. And if it is associating, formula is 1 plus 1 upon n minus 1 into beta, where 1 upon n, as in here, there n will be the if acetic acid is dimerizing, so n will be 2. Somebody trimerizes, then n will be 3. What is alpha and beta? Alpha and beta are the percentages. I'll be doing that in question. I'm just iterating them. Here they are giving no information about the type of solute, so we will just consider I as 1. Now, so considering I as 1, KB is given to be 0.5, and what is the now concentration term we already know. So amount of solute we have to calculate. Molar mass of solute, the question is given the amount of solute. Yes, amount of solute we have to calculate. Molar mass of solute is 100 gram and weight of solvent is 100 gram, so 1000 will come in the numerator. Now this is just a mathematics now. Yes, it will take time, but that is your job, guys. So I hope once you solve it. Perfect. We still have people here. We still have people solving with me. MD Zaid. Perfect, beta. Kala Gunda. Kala Gunda Patil is also saying C. Perfect. Moving to the next one. Next question says an aqueous solution of non-electrolyte. Now this is saying non-electrolyte, matlab, that means here also you do not have to consider the case of dissociation and association of the solute. So here also I is 1. Now it boils at this much. Because it is giving you temperature and because it is saying aqueous, that means solvent is water. So delta TB will be pressure of solution minus temperature of solution minus temperature of solvent. So this minus 100. So delta TB will be equal to 0.52, which will be equal to I is 1 kb for water. Sometimes it is not given in the question, so you have to learn this. kb for water is 1.86 Kelvin kg per mole. kf for water is 0.52. Unit is the same, Kelvin kg per mole for water. Because it's a universal solvent, you have to remember kb and kf values for water. I hope I'm making myself clear. So this will be equal to I is done, kb is 1.86 into an aqueous solution boils at the freezing point. Okay, it is just asking about the freezing point only. So delta TB will be equal to I into kb into molality, and the delta TF will be equal to I into kf into molality, because the question is saying that you have to calculate for the same solution. That means you do not have to bother about the concentration because it will be same. You do not have to bother about I because it is also saying it is non-electrolyte, although if it is not given, still it will be getting cancelled. Delta TB value is given, which is 0.52. Delta TF, let me calculate. It will be equal to kb is 1.86, kf is 0.52. So I can clearly see, I guess this will be 1, 2. So you just have to solve, and I guess once you solve this guys, what is it? 1.86. You have to be good with your calculations sometimes. 0.3. 0.52 is this only, I guess. kb. Okay, beta, we have missed the one logic. Actually, I've interchanged the value of kb and kf. I beg your pardon. I've interchanged the value of kb for water is 0.52, and kf, I beg your pardon, kf for water is 1.86. I'm sorry. Yes, you people also commit such mistakes during attempt of your examination, so make sure we don't do it. So this will rather help us ease the calculation as well. So delta TF will be equal to 1.86. Now delta TF is nothing but it is equal to TF, because it is decreased, so TF naught minus TF is given out to be 1.86. Now for solvent, we know it is 0 degrees Celsius, so TF naught, which is of solution, will be clearly minus 1.86. So your answer will obviously be 2. Although I tell you one thing. For freezing point, sir, it is always depressed. If you add a non-volatile solute, freezing point will be depressed. I am saying that if such question is coming in your examination, here I was explaining you with complete detail, but in your examination, ultimately you need ABCD. You do not have to move your pen for this question. You know why? Look at the options. For depression in freezing point with respect to solvent water, it will always be a negative value. We only have one option which is negative. So for such a question, yes, NTA do it most of the time. Most of the time NTA do it. They ask you to be calculative with your question. But if you just have a fresh eye on the options, you may not even have to attempt it. I hope it is good. Dharmayu, the only problem we were having is I have miswritten the value interchange the value of kb and kf. Actually value of kb is, that's why I've done this with highlighting, with using different colored pen also. kb is actually 0.52, 0.52, some references say 0.53, and kf is 1.86. I hope we are clear till here. Moving to the next one. After delta TB and delta TF, the question comes is for the last colligative property, which is osmotic pressure. Now, osmotic pressure pi is also equal to I into CRT. The osmotic pressure of 0.2 molar solution. Now, although it is given molar solution, but let me tell you one thing. Colligative properties are also valid for dilute solution, and for dilute solution, molarity is approximately equal to molality. You should know this. For dilute solution, you do not have to bother that whether molarity is given or molality is given. So osmotic pressure you have to determine because it is urea, so organic compound do not dissociate. So this will be 1. Concentration is 0.2. For osmotic pressure I need molarity only. So ultimately, even if we do not know this, but know this for good questions, because here I need molarity only. So molarity is 0.2. Value of R is 0.082. For ease of calculation, you can take it as 1 by 12 into temperature is 300. So this is just simple calculation after this. So if you calculate, your answer will be 4.92. Moving to the next question. Now, Van 't Hoff factor, I'm writing the formula for Van 't Hoff factor. It is equal to 1 plus n minus 1 times of alpha in case of dissociation. And I is also equal to 1 plus 1 upon n minus 1 times of beta in case of association. When when the solute, people get confused with this, so I'm giving you example also. When solute is getting dimerized, then just put n as 2. Similarly, trimerize, so you just have to do this in the denominator, that's it. Now, how to calculate? Those acids thing will not be given to you. So for a NEET level of paper, it generally does not come, so I'm not giving it. So for example, over here, for this salt, alpha is not mentioned, so generally salts are strong electrolytes, so alpha we'll consider, if not given, we'll consider as 1. So alpha is 1, that means I is nothing but n. What is the number of ions that it is giving? K4 Fe or FeCN6 will dissociate in water and will form 4 potassium ion and 1 complex anion. So ultimately, how many ions I am getting? 4 plus 1. So value of n is 5. So answer will be 5. Such questions you are going to be over flooded in your NEET examination. Moving to the next one. Now same. For the same question, if alpha is given, so I will be equal to 1 plus, again n is 5, so 5 minus 1 is 4 into alpha, but here alpha is not 1, rather it is 0.8, so 8 4 32, so this is 4.2 as an option 4. So if alpha given, kindly do accordingly. If not given, take it as 1, because for salts alpha is generally 100%. Moving to the next one. Calculate apparent degree of ionization of an electrolyte. So now here it is asking about alpha. Mx2 in water, Mx2 as in it will form M plus 2 and twice of X minus, that means number of ions are 3. If observed molar mass of solute by measuring elevation and boiling point is itta. Okay, so if the observed molar mass of solute measuring elevation and boiling point is itta. Okay, colligative property is maximum used to calculate molar mass of solute. And what is this correction factor, Van 't Hoff factor? It is colligative property observed as an experimental value upon colligative property theoretical as in the formula that we know. Because that's why we are doing this correction factor. And colligative property is a property which depends on number of moles of solute. Number of moles of solute is weight upon molar mass. So colligative property is inversely proportional to molar mass. So if you do the ratio of I in terms of colligative properties is experimental upon theoretical, but in terms of molar mass, it will be molar mass of solute experimental upon molar mass of solute theoretical. Now, if I know a solute, then theoretically whatever molar mass I know will be my normal value. So sometimes theory says that theoretical value is the normal value and experimentally if I am getting something different, then I say experimental value is the abnormal value. I hope now the English of the question is clear to you. Now the question is telling us that if the observed molar mass is this, so this is my observed molar mass, as in observed, if the observed molar mass as an abnormal value is given. So I will be equal to whatever theoretical value I have upon observed is 65.6. Okay, normal molar mass is also given. So rather let me put it directly. Normal molar mass is given out to be 164. So here with this, I hope you can calculate value of I. So value of I will be the ratio. What ratio? Because colligative property is experimental upon theoretical. So molar mass will be theoretical upon experimental. Theoretical, whatever we get, we feel it is normal. So this is normal molar mass upon experimental molar mass as an observed molar mass. The question is giving you normal molar mass as 164 and observed as 65.6. So I guess 65, this is 130. So this is somewhere around 2.5. You just have to approximate. So I is given to us, and I is equal to 1 plus n minus 1. N is 3. So 1 plus 2 alpha. So 2 alpha will be equal to 1.5. So alpha will be equal to 0.75. So answer will be, what is percentage into 100? So answer will be clearly 75%. I hope a very good question, a very logical question, but I hope everybody is clear with this. Beta, questions, whatever the questions I am having over here, it is through the team, and obviously we at PW belong to the same team. So the question selection, because we take classes, I mean personally I take classes in the JE section also. So the questions we have definitely supported each other with, because these are the most probable questions. So the point is, beta, ultimately your happiness, your result will only be done once we have got selected questions. So I am not in the initial slide only, I told you that these are selected questions from our team, and obviously team is same for PW. Chalo, moving to the next question. Chalo, maximum. You people are super awesome sometimes. Chalo, question says maximum lowering of vapor pressure is observed in case of, so beta, now lowering of vapor pressure is P naught minus PS upon P naught. Yes, but P naught for a solvent, it is constant. It is proportional to number of moles of solute upon number of moles of solution, but number of moles of solute will come with a factor of I. So more will be the value of I, more will be the lowering. I hope everybody is clear. So maximum lowering will be observed where I will be more. Here I is 1 because organic. Here it is 3. Here it is 2. And here it is also 2. But with concentration, because concentration will also be multiplied, no? So this has highest I. But 3 into 0.1 will be 0.3. And 60 into 2, or 30 into 2 will be 60. Obviously, this will have the maximum value, because although I is not concentration. Okay, so beta, I guess concentration will be, ultimately you have to calculate the number of moles also, and number of moles will also decide. So 30 into 2. If it is given, okay, I am again telling you, see, I into number of moles will decide. Number of moles is also dependent upon concentration. So here they are changing the concentration also. So never do this mistake, just that you should only see value of I. You should see the value of concentration also, because concentration will give you number of moles, and number of moles of solute is high. So here multiplier is getting more, although I is greater over there. I hope you are getting the point that I'm making over here. Sometimes the question tricks you that I will be larger for other species, but concentration they have increased for other species. More will be the concentration, more will be the lowering. You can obviously see. So a good question, I feel. Moving to the next one. Which one of the following equimolar aqueous solution will have maximum freezing point? So which will have maximum freezing point? Freezing point as in delta TF is proportional to I, agreed. But delta TF is TF not minus TF. So if I is more, then change is more. If change is more, then freezing point of solution is less, because here freezing point of solution is subtracted. Remember this. Now, the question is saying which of the following will have maximum freezing point. So if I need maximum freezing point of solution, that means I need minimum I. So minimum I is of what species? So let us calculate I for these complex salts. This complex salt will give 1 cation and 3 anion. So I will be 4. This will give 1 cation and 2 anion. So 3. This will give 1 complex cation, 1 anion. So 2. This will just have one species because it is a here we only have water of crystallization. This is only one complex. So this will have lowest I. Nah, not answer 3 beta, option 4. I hope everybody is clear. I hope okay, so this is the last question that we have. Then we will depart for a break. Uh, we'll take 15 minutes break, है ना? भाई translate कर दे. No. I have chalo. Moving to the last question, beta. Then we'll start with redox and atomic structure. What is freezing point of a solution containing this much gram of HBr in 100 gram water, assuming the acid to be 90%? Again, the same question, beta. You are assuming acid to be ionized, to be 90% ionized, and Kf is given. So freezing point. So ultimately, delta Tf is what? So delta Tf is I into Kf is given into molality. Molality is weight of solute, which is 8.1 gram, upon molar mass of solute. Molar mass of solute, I guess we have to, no, molar mass, okay, let us calculate molar mass of HBr. So let's say 80 plus 1, because with mass only you can see that it should be getting cancelled. So molar mass of solute into weight of solvent is 100 gram into 1000. So these many things I know. The only thing I need to calculate is first I, and then I can have TF, because delta TF is nothing but TF naught minus TF, because TF for water is 0 degrees Celsius. So as you calculate delta TF, just put a negative sign and you'll be getting your answer. Now, only thing is left over here is the calculation of I. So I will be equal to 1 plus n minus 1 times of alpha. Here for HBr, it will make 1H plus 1 Br minus, so n will be 2. So 1 plus 2 minus 1 is 1 plus alpha. What is value of alpha given? 90%. So this is 1.9. So I value also I know. Just put that value over here and I guess you will land with option 2. Yeah, perfect. Sonam Yadav. Sir, is this enough for physical? More than enough, beta, for the chapters I have discussed. But yes, for the chapters I have discussed. And I have tried to discuss each question with loads of conceptual details. Although I have not written those details because this is not the time to write questions. But I hope you are in sync. Now, we are departing for a bio break because, so this is what? This is 1-4. So we will meet at 1:15 p.m. Okay, chalo. So we'll meet at 1:50 p.m. By the time you can get up from your seat and have your bio breaks and lunch. Hello, 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 hello. I'm sorry, guys. Yeah, I'm sorry, guys. Yes, good, good afternoon again. So yes, I'm sorry, guys. Actually, I'm having that class in the evening also, the batch classes and a live at J channel. So just having a word for that. So I'm sorry, but yes, we are I guess 4 minutes late. Chalo, no worries. Chalo, guys. So here from here we are starting from redox. We are starting from redox. Now, why I have deliberately coupled mole, then solution, and then redox? Because NT also loves it. The JE paper was also having this trend of mixing questions. So obviously your 45 questions of chemistry will also be coupled. So I hope you can check the idea that why I'm coupling these chapters for you. Moving to talking to directly basics. Yeah, Arya is giving me answer also. So perfect, Arya. Option according to Arya, she's saying 3. I hope Arya is a she. So the question says conversion of potassium dichromate to potassium chromate. Now, potassium dichromate to potassium chromate, the oxidation of chromium changes from. So for that, we just have to calculate oxidation state of this chromium. Let's say this is X. So plus 2X minus 7 2 ja 14 equals 0. That means this X is in plus 6 oxidation state. If we do that for potassium chromate, here also I can say plus 2 plus, let's say its oxidation state is Y. So minus 8 equals 0. So sir, here also it is coming out to be plus 6. So because there is no change in the oxidation state, so obviously it is remaining the same. I hope everybody is clear. Plus 6 to no beta. No, Arya. It is not getting decreased. It is just the same. In fact, you should know it is a D block, very famous D block logic also. NTA loves. NEET will be asking you about what D block side of inorganic chemistry, potassium dichromate and KMNO4. K2Cr27 stays in acidic medium. Once you make the medium basic, then it converts to yellow colored potassium yellow colored chromate ion. So very famous inorganic logic as well. Moving to the next question. I need answer, guys. Now, the question says, in which of the following oxidation number chlorine has oxidation number plus 5? So this is also common sense of oxidation state calculation. Here it is minus 1. Here this is X minus 2 equals minus 1. So chlorine will be plus 3. So similarly, here it will be X minus 4 equals minus 1. Okay, I'm sorry. Here it will be plus 1 because this is minus 1. Okay, I'm sorry, this is minus 1. So once it will go over here, it will be plus 1. This will be plus 3 and this will be plus 5. So just algebraic sum will give you the answer. I hope everybody is clear. Moving to the next one. Now you have to calculate the oxidation state of oxygen in potassium superoxide. Oxide is generally minus 2. In peroxide, oxidation state of oxygen changes to minus 1, and in superoxide, it changes to minus half. I'm not saying charge is fractioned. Actually, as a molecule, oxygen bears minus 1 charge. So per atom, the average charge given is minus half, and oxidation state is the partial charge. So I hope everybody is clear with this too. Moving to the next question. Yeah. Now the question says, which of the following behave as both oxidizing and reducing agent? Now what is an oxidizing agent, beta? Oxidizing agent oxidizes others and reduces itself. Reducing agent reduces other and oxidizes itself. What is oxidation? Oxidation is loss of electron. What is reduction? Reduction is gain of electron. How can you lose or gain electron? If you are in an intermediate oxidation state. If you have more capacity to give also to take also, then you can obviously disproportionate. If you are standing at an extreme, then you can't behave both ways. So just calculate the oxidation state of the central atom if it is at extreme oxidation state. then it can't behave as both. For example, here sulfur is in +6 oxidation state. What is the number of valence electron present in sulfur? Sir, 6. So it has given all the 6. So can it give more? No. It can only take electrons. So here sulfur can only undergo reduction, and because it will reduce itself, so can only act as a oxidizing agent. Question is asking us it should behave as both, so it is wrong. Yes, obviously, if sulfur is in +4 state, so it can oxidize also, +6, it can reduce also. So obviously option 2 is your right answer. Here sulfur is -2, so this can only oxidize itself, so it will only act as a reducing agent. And nitrogen here is in +5 oxidation state, maximum oxidation state, so this can also, it can only reduce itself, so it can only act as a oxidizing agent. So option 2 is your right answer. I hope yeah, row 1 is right. Moving to the next question, guys. Reaction this. Now such questions find lot of application in your NEET examination, beta, so please make note of it. The question says the reaction of H2S, you have to make the reaction of H2S with water. So let us see, sulfur is going from -2 state to 0 state. That means oxidation of state of sulfur is getting increased, so it is oxidation. H2O2 from -1 oxidation state, it is going to -2, so that means it is getting reduced. So if I am getting reduced, how H2O2 is behaving? It is behaving as a oxidizing agent. I hope it is clear to everybody. Moving to the next one. Now next thing comes for a redox reaction topic is the balancing of redox reaction. So how you balance a redox reaction, guys? Yes, there are two methods, oxidation number method and ion electron method. Technically speaking, for a good question, you should know ion electron method, but I am telling you, for a NEET level of examination, oxidation number method is more than sufficient, because there you are able to write the complete balancing in just a single line, and time is money for you. So we'll definitely use oxidation number method only. So let us try and balance this. It will help us to have an understanding. So permanganate, as in +7 ion, which is MnO4 minus. So MnO4 minus in basic medium oxidizes I minus, and it oxidizes I minus to I2. And because it is basic medium, so MnO2 will itself gets reduced to MnO4 minus will itself get reduced to MnO2. Now, how to balance it using oxidation number method? Just find the oxidation state. So oxidation state of manganese here is +7. Oxidation state of manganese here is +4. So what is the charge transfer, beta? From +7 to +4, I have to gain how many electrons? 3 electrons. Now iodine from -1 state is going to 0 state, but first balance, because these are two iodines, so I need to have 2 over here, because I need 2 iodines, so atom must be balanced. From -1 it is going to 0. That means 1 is giving 1 electron, but I am having 2 species, because 1 molecule I need to form. Therefore transfer of 2 electrons will be taking place. Now you have to equate the charge transfer. How shall we equate the charge transfer? If it is giving 3 slabs and it is taking 2 slabs, then ultimately I have to multiply this by 2 and this by 3, so that the slapping each other gets equated. So this is also 6 and this is also 6, so this is the least fraction that we have to use. So ultimately this 2 I will multiply here also and here also. This 3 I will multiply here also, so 3 into 2 becomes 6 and this becomes 3. Now, I hope you can see atoms are balanced, but oxygen and hydrogens are not balanced. So how to balance them? If the medium is basic, use OH minus. If the medium is acidic, use H plus. Now, basic here, let us check for hydrogen. Okay, it does not have any hydrogen. So let us first balance for oxygen, or let us balance the charge. Here the charge is 0. Here the charge is -2 and -6, so -8. Here charge is -8, here charge is 0. So in basic medium, what shall I use? Because question is saying medium is basic. So what shall I use? OH minus. To do what? To balance charge. So let us use OH minus. How many OH minus I need? I'll be needing 8 OH minus because I need to balance this 8 minus. Now, how many hydrogens I have? 8. How many hydrogens I have over? 0. So that means if I take water to balance hydrogen, I'll be needing 4 water. And in a single line, you will be able to balance your reaction using oxidation number method. Yes. Technically, all the reactions cannot be balanced by oxidation number method, beta. But yes, for your NEET level of examination, it will be done, because if at all it is asking ion electron method for a question, then that question will be taking time. I'll be discussing that, like for the example this question, let me do this question with ion electron method also for all the students, few of the students who will be having this feeling that no sir, please tell ion electron method, because we want to score the maximum, because some reactions can only be balanced using ion electron. So let me give you ion electron method also. Ion electron method says, like for example, I have MnO4 minus changing to MnO2. So you first balance first half. How to balance first half? First balance element manganese is 1, then then add water to balance oxygen. How many oxygen I have? 4. How many I have? 2. So how many oxygen I need? 2. So how many water I should add? 2. Add water to balance oxygen, then add H plus to balance hydrogen. How many H plus I'm having? 4. But sir, medium is basic. So beta, if medium is acidic, then do till this and the balance charge. If medium is basic, then add equal number of OH minus ion on both sides. Like for example, I have 4 H plus ion, so I'm adding 4 OH minus ion also in left side also and in right side also, because H plus and OH minus ion will interact with each other and they'll form water. So water will now be getting simplified. So I have 2 water over here cancelled, so 2 water will be remaining. And now you balance charge. How to balance charge? In order to balance charge, calculate. This is -1 and here this is -4. So I'll be needing 3 electrons on the left hand side. This is how, because it is eating up electron, that means this is the reduction half of the reaction. Now we balance the oxidation half of the reaction. Oxidation half will be, who is getting oxidized? I minus is oxidized to I2. So I add 2 over here. There is no oxygen and hydrogen, so simply I'll balance charge and 2 electrons will balance the charge. Now here coefficient is 3. Here coefficient is 3. So I multiply this complete equation by this 2, so that 2 into 3 becomes 6. So this is charge transfer I'm equating, and I'm multiplying this equation by 1. After multiplying, you shall add both the reactions and now you will be getting a complete reaction. But sir, it is a very tedious job. Yes, that's why I'm saying, for a simple question, as a question you get in your NEET examination, you can clearly do oxidation number method and it will be balanced in a single line. The reason I've told you ion electron method is because some questions, some redox are not balanced by oxidation number method. But yes, for a NEET level of examination, you can assume that oxidation number method will work, and it 99% of the time it works. So but I've given you that for 1% of the time I've given you the detail. Now again, this question will be a homework for you. Balance this with oxidation number method. I hope you can do this. Moving to the next one. Now here I'm having options, so I want you to do this. Give me answer. Give me answer. What's the duration of the class? Beta, we'll be finishing by 3. Around 3 we'll cover, because we'll be meeting tomorrow also, because physical chemistry I have broken in 2 halves. First half I'm taking today, second half I'll be taking tomorrow. Perfect. Chalo. Answer guys. Hello sir, good afternoon. Ankita Pal. My coffee got cold. Chalo, I have this jar so that I can keep on sipping small amount. Chalo, moving to the next one guys. The next question says MnO4 minus, sir. Again, you said balancing by oxidation number method is best, so that is what we are doing. This is MnO4 changing to Mn plus 2. So here oxidation state of Mn is, sir, this is X minus 8. So this is plus 8. MnO4, it should be MnO4 minus beta, I guess. Yes, it should be MnO4 minus. That's a printing error. This is MnO4 minus. So here oxidation state of manganese is plus 7. So from plus 7 it is changing to plus 2. So transfer is of 5 electrons. And what about carbon? Carbon over here is 2x minus 8 equals minus 2. So 2x is equal to 6. So this is plus 3. And here it is plus 4. So from plus 3 to plus 4, the change is 1, but because I have 2 carbon in oxalate ions, or 2 will be multiplied. So this is asking for 5 electron, this is asking for 2 electrons. So what shall we do? Multiply 2 over here, multiply 5 over here, and that is what I'm going to do with the species also, as in MnO4 minus plus C2O4 2 minus, giving me Mn plus 2 and CO2. Now because I know the coefficient, so I'm directly putting them. For manganese I have to use a multiplier of 2, so 2 and 2 will be balancing elements also, and the transaction also. And for oxalate ion I need a multiplier of 5, so this 5 and but yes, I'm sorry, because this is 2, so a 2 will definitely be here, and when this 2 will be multiplied by 5, it will be a 10 over here. I hope everybody is clear with this. Now after that, because medium is acidic, so balance charge by using H plus ion. What is charge in left hand side? So 10 and 2 as 12. What is this? So here left hand side is having minus 12 and right hand side is having plus 4. What I have H plus. How many H plus I should use? I should use 16 H plus. Why? Because minus 12 will become 0 and I need 4 extra plus because this is plus. Now to balance hydrogen I will add water. So hydrogen I have 16, so I will add 8 water. I hope it gets maybe it is getting simplified. No, this is the most simplified equation. So let us check what coefficients they are asking. For MnO4 minus, coefficient is 2. So these are the options. For oxalate ion, coefficient is 5. So option 2 is my right answer because H plus is 16. I hope everybody is clear. Sir, is this helpful for... Yes, beta. Beta, see, what I have been doing for you is I have selected the logics of NTA from NCERT. That is what all the medical colleges examinations, whatever examinations you are having, anxiety is getting high. Arya, practice more, then you'll be not having any sort of feeling. If you're practicing less, you're thinking more, and more thinking will bring on anxiety. So rather, beta, practice so much, get yourself involved in revision so much that you don't have time to worry because you have time to work. Moving forward, I hope everybody is with me on this. Moving to this next question. The question says, for these, choose the correct statement. Now, obviously, I can see F minus will have 10 electrons, O2 minus will have 10 electrons, and neon obviously has 10 electrons. So they are isoelectronic species. So this is correct. All species have equal number of... This is the definition of isoelectronic species. So yes, obviously, all the options are correct. I hope... Now, if you are getting such question in your NEET examination, do you need to have anxiety, or do you need to work and practice more and more questions? Work and practice more and more questions. Rather having that feeling after Sunday, have that feeling today. Have that feeling initially only, then you will definitely land to your dream college, beta. Moving to the next one. Next question says, now we have okay, with this we have came to the last chapter for today, which is atomic structure. The last chapter for today is atomic structure, and we have come to atomic structure with this question. Now Which of the following statement is not correct regarding cathode rays? So, cathode ray experiment was the experiment by which we have discovered electrons. So, cathode ray originate from cathode. It is obviously correct. It is asking us not correct. Make sure that you are reading questions correctly, because it is saying not correct because it is correct, so not an answer. Charge and mass of particle constituting cathode ray depends on the nature of gas. No, because every gas will produce electron, and electron charge to mass ratio is same, so it is not dependent on the type of gas. Yes, for anode ray experiment it is dependent. It will change as the gas change. So obviously, because it is saying depends on, therefore it is incorrect, and because it is incorrect, therefore it is an option for us. Sir, is titration important from redox reaction? Beta, as such, normality, you should just know that how to calculate normality. Normality is molarity into valency factor. Valency factor for acid is number of H plus that they give. Valency factor of base is number of OH minus ion that they give. Valency factor for a salt, a normal salt, is the total charge of either cation or anion. And valency factor for a redox entity is number of electron transferred. You just do the oxidation method and you'll get to know that what is the charge transfer. Now, whatever titration, acid-base titration, redox titration you're given, just equate the number of gram equivalent. Number of gram equivalent is number of moles into valency factor. Valency factor you can obviously calculate. So yes, some of the redox reaction questions may come. So then why you have not taken those questions? Because I have taken the balancing question. So that balancing question will give you the basic, will give you the logic. Okay, chalo, moving to the next question from atomic structure. Atomic structure, NTA find very I mean these questions find lot of application in a NEET examination beta, because now they are not asking the formula directly, rather they are asking the theory around it, so that all the students who have mugged the formula, they'll not be able to attempt that theoretical questions. So please, statement based questions are finding lot of application in the JEE examination, and definitely they'll be finding application in NEET examinations as well beta. So that's why I'm bringing these questions also to you. Now, according to Thomson model, the amount of deviation of the particles from their path in the presence of electric or magnetic field depends upon, now a very logical, I guess you know these things from class 9th or maybe 10th, but still let us attempt. I've taken such questions which will give you logic also. Now, the magnitude of negative charge on the particle, more be the charge, sir, more will be the diffractions. Obviously this is correct. Mass of the particle, if I'm heavy, I'll be deflecting to lesser magnitude. If I'm light, I'll be deflecting to a larger magnitude, so this is also right. The strength of electric and magnetic field is actually applied on the charged particle, because of that deflection is observed, so this is also correct. So actually all of these are correct, sir. Why you have taken this? Because now with this I'm making you revise the deflection method also. Moving to the next one. Now, next question says, E by M ratio of cathode ray experiment is X. E by M ratio for electron is X, because cathode ray experiment is discovery of electron. Now, when hydrogen is filled in discharge tube, okay, what will be value when deuterium, sir? For electrons, every gas, either hydrogen or maybe deuterium, is a heavy nucleus, but ultimately it is having how many electrons? The same number of electrons which hydrogen has. So E by M ratio for electron will remain the same, so it will obviously be X unit, a simple application of what we have seen in the previous question. I hope everybody is good. Moving to the next one. Now, again that E by M thing beta. Now the question, now you just take 30 seconds for this and attempt this. I'm not using poll because my poll is not even working, but I'm not using poll, but try and answer this beta, because I have explained this E by M to you. I want you to actually attempt this. This is theoretically point of view, it is a good question. Theoretical point of view. Ankit Pal is saying 1, yourself, name, try. I have poured some coffee for myself. Answer, guys. 4, yes. Yes, Ankit Pal. Yes, Kundapura. Yes, beta. I'm very sorry if I'm uh, pronouncing your name inappropriately. I'm very sorry. I hope you have the feeling. Chalo, moving to the question. The question says, which is true? E by m value of cathode ray generated by discharge tube by different gases are different. Sir, for cathode, again the same thing. Sir, cathode rays we find electrons. Whatever gas produce electron, electron will be electron only. So E charge by mass of electron will remain the same. So this is obviously incorrect. E by m of anode rays generated by discharge of different gases is same. No, sir, because anode ray is for production of positively charged ions. Positively charged ions, for hydrogen it is H plus, that means it's just a proton, but for helium it will be He plus 2. Helium mass, helium is having 2 protons and 2 neutrons. So charge by mass for positively charged, that is for anode ray experiment, it will be dependent on the gas, and it is saying it is same. No, so this is also incorrect. It will be same for cathode and different for anode. I hope I am making myself clear now. E by m of proton and E by m of electron. Sir, charge for both are same, and mass of proton upon mass of electron. Mass of proton is not large. It is 1837 times of electron. So obviously, sir, this proton is very heavy. So if denominator is large, then this ratio will be less. So this is definitely incorrect. What will be the correct value? This will be the correct value. And obviously we are having option 4. So option 4 will be our right answer, because for proton, electron is charge is plus E, mass of proton is, let's say, m. For alpha particle, charge is 2e and mass is 4e. So mass is 4 into mass of mp. Sorry. So this is 1 by 2 and that is 1 by. So this is 1 and this is half. So obviously half is less. So option 4 is correct. Easy question. Easy question, but beta, the representation will take time. है ना? So expect them for your NEET examination. Now, Rutherford, theoretical questions first. Rutherford experiment which established the nuclear model of atom used a beam of, so everybody know it used alpha particle, and alpha particle is nothing but it is helium plus 2. So not beta, not gamma, not helium atom. It used helium nuclei which impregnated on a metal foil and got scattered. Helium atoms, because it is strictly saying helium atoms, therefore I am cancelling. It is saying helium nuclei. Yes, nucleus of helium is used which is positively charged. है ना? Chalo, moving to the next question. This one, attempt this one, guys. Now, maximum frequency. Now we know frequency and wavelength of electromagnetic radiation are inversely related, where formula is nu is equal to c by lambda, where this is speed of light, values 3 into 10 raised power 8 meter per second. Now, in this, you have seen that NCRT picture. In this direction, frequency increases, and in this direction, wavelength increases. Who is the highest frequency radiation? Sir, cosmic rays. After that, gamma rays. So an NCRT fact, a very beautiful question, because it's an NCRT fact. Everything revolving around NCRT is beautiful, also highly probable also. Moving to the next question. Now, this question is just will be testing your mathematical skills. So a particular station with frequency. So actually this is my frequency. So nu is given as 1368 into 10 raised to the power 3 hertz. This is nu. Wavelength of electron emitted by, so this yes, it'll check your mathematical skills. That nu is equal to c, which is 3 into 10 is power 8 upon lambda. Nu, you know, if you just put the value, you will get your value of lambda. Yes, mathematical skills is definitely required, and once you solve it, options are also close enough, beta, so you have to be really religious with your calculations. I hope you can do that. The practice you have to do, calculate it and get the answer rectified by yourself. That will also enhance your speed, guys. Moving to the next question. According to electromagnetic theory of Maxwell, which one is incorrect? Now, Maxwell was the person who challenged Rutherford model, Because Rutherford said electron is revolving around the nucleus. Maxwell said any charged particle who revolve around any charged particle who is accelerating will continuously lose electrons. And it proved also that in a frame of around 10 raised to power minus 8 seconds time order, electron will lose so much of energy that it should combine with nucleus and atom should get destroyed. So this was postulated by whom? This was postulated by Maxwell, and Maxwell was the person who uh, who crashed the theory of Rutherford. So what Maxwell said, that charged particle when accelerated should emit electromagnetic radiations. Yes. So obviously what shall be your answer? Option 1. Moving to next question. The next question says, now the energy E1 and E2 of electromagnetic radiations are given, and you have to now energy is equal to h nu or hc by lambda. So energy is directly proportional to frequency, but it is inversely proportional to wavelength, and in this question wavelength is asked. So let us do this. So E1 by E2 will be equal to lambda 2 by lambda 1, and energy ratio is given out to be 25 upon 50. So this is 1, this is 2. So this lambda 1 is nothing but twice of lambda 2, which makes option 3. A simple question, but yes, a probable logic for your NEET examination, guys. Moving to next question. The question says the photons of light having wavelength this much, so this is my lambda, are necessary to provide this joule of energy. Now I need the number of photons. So what is total energy? Each packet, each photon has energy hc by lambda. So 2 photons will energy how much? 2 into hc by lambda. So n photons will have how much energy? N into hc by lambda. What is the total energy I need? 1 joule. What is the number of photons? N will be required. What is the multiplier hc? You can learn it also. It is approximately 20 into 10 to the power minus 26. The multiplier hc in joule. You should learn this data. It will make your calculations easy. And 4000 into 10 raised to the power angstrom, as in 10 to the power minus 10 meters. Now you just solve, and once you solve, it is very easy also. It is very doable also to solve. You will get your answer as option 3. I hope everybody is clear, guys. Perfect. Moving to the next question. Now here, I mean, this is also the same question, but here power is given. What is power? Work done per unit time. So power is work done. What is work done? The total energy that it is supplying. So the total energy supplied per unit time will become power. It is equal to number of photons into hc by lambda. So time question is asking you to give this in 1 second. So time is 1 second. If it is 1 second, then definitely this total energy is 100 joule per second, because power is watt is joule per second. So this is 100 upon 1. Number of photons it is hours, so this is 20 into 10 raised to the power minus 26 upon lambda. Lambda is given out to be 560. So 560 nanometer. How I do this nanometer calculation? Deci, centi, milli, micro, nano. Fifth finger. So -1, -2, -3, -6, -9. If you remember it, good. But you can also use your fingers to find your answer. If you do the calculation correctly, I guess you will land with option 3. Moving to the next question. Now, moving to photoelectric effect. Definitely you are going to get a question from this. What is photoelectric? In your physics also you do this lot of times. So whenever incident radiation fall, let's say energy is in EI, it falls on the metal surface, electron take that energy, move to the surface with energy required is work function energy, and if at all it is having energy after reaching the top, it ejects with some kinetic energy. So incident energy is equal to kinetic energy plus work function energy, but I can only gain this kinetic energy once the incident energy is more than work function. So let us, the question is asking you that whether it will photoelectric effect will occur or not occur. It will only occur when incident energy is more than phi, and once you calculate you will find the value of phi, the value of work function. Will photon having radiation energy, value of work function, the threshold frequency is given, okay? So with threshold frequency, you can find phi, which is equal to h nu naught. So here you can find the value of work function, and this is your incident frequency. So incident energy will be equal to h nu I. So obviously once you will solve, you will see that incident energy is not sufficient, but yes, calculation you have to do because incident energy is not sufficient. So you tell me whether rejection will take place. No sir, it will not take place. That means it will not occur. But yes, this is a homework for you. Why? Because the calculation you have to do, it will also make you confident with your logic as well. Moving to the next one. Now this question says the threshold frequency nu naught for a metal is given. Okay, calculate the kinetic energy of the electron emitted when frequency. I mean, just the same thing, but the only thing you have to do is you have to calculate the kinetic energy. How you will calculate that kinetic energy? Sir, incident energy minus work function. Frequency are given, so incident energy is h nu I, kinetic work function energy is h nu naught. For the metal, nu naught is this. For the metal, for the incident radiation, nu I is this. So h value you take as 6.626 into 10 raised to power minus 34. Whatever difference I am getting over here, so that it is calculation is also quite easy. It will be 11 into 10 raised to the power 14. So 11 minus 6 is 5 into 10 is power 14. So just the calculation, if you do this basic into divide, I'm not saying it is easy beta. Why? Because those students who are practicing hard, who are practicing and solving questions again and again, only those students are going to crack the actual paper also. So that is why I'm here to help all the students for practice also, and to help those students who are not comfortable with logic. So I'm explaining logic also. I hope I am making myself clear. After completing the question practice, please guide about how to approach chemistry. Sure, beta. Arya, beta, see, first of all, you need to find the areas where you are comfortable. Attempt them first and the remaining later. This is the basic and first approach that you should follow. Chalo. Moving to the next question. A very important logic, a very important conclusion here also. Beta, you have to say that which graph is incorrect based on photoelectric effect. Now, kinetic energy is directly proportional to the frequency of incident radiation. The high energy packet you give, the more kinetic energy, because energy is always conserved. But yes, the number of photons ejected has nothing to do with kinetic energy. It only has to do with the intensity. Intensity is nothing but intensity is dependent upon the amplitude. Like an electron wave is coming, the amplitude of electron wave decides the intensity of that particular wave. In general, it is the brightness, the number of packets. So number of packets increases, when number of packets increases, the number of electrons getting ejected will also increase. But number of packets only depends upon the intensity of radiation. You should know that. So kinetic energy with frequency, it is definitely correct. Because it is correct, so not an answer, because question is asking us incorrect. Intensity deals with number of photons, that also I know. So because this is also correct, so not an answer. Intensity and kinetic energy, no sir. Kinetic energy is not related with intensity. So obviously this is incorrect, so an answer. Intensity and kinetic energy, yes. Kinetic energy has no effect if you change intensity. So this is also correct, so not an answer. A very important conclusion. I hope everybody is with me. Chalo. Everybody is with me. Okay, moving to the next question. The next question says, when the frequency of incident radiation on a metallic plate is doubled, if you double the frequency, kinetic energy of the photon will. Sir, I know kinetic energy is equal to h nu I minus h nu naught. It is a constant, so let's say it is A. Now this is my kinetic energy 1. Kinetic energy 2 will be h nu I, but I am doubling the frequency, so this is twice minus constant. So you tell me how much of kinetic energy 2. So kinetic energy second minus kinetic energy first will be equal to twice nu, taking nu, so 2h minus h, that means h nu I. So if I'm doubling the frequency, ultimately the value is multiplied with h also. So the increment will be more than double because that value will be multiplied by h. So whatever frequency increment will be there, that increment will be further multiplied with h, and h will have a more increment on the kinetic energy, so it will be more than doubled up. Yes, perfect, most of you are correct, attempting it correctly. Perfect, guys, I love this. Good. Moving to the next question. Now, photoelectric with number of photons emitted is proportional. Sir, we have done this. Now, Bohr. Now, after that, coming to Bohr theory. Now, what does Bohr theory tell us? Sir, Bohr theory tell us that it has different postulates. That according to Maxwell, electron should enter, then should meet the nucleus because it is continuously losing energy. Bohr said that yes, it is losing energy, but not at the cost of itself. It is taking energy from outside. How much packet of energy it has taken, according to that it chooses an excited state, revolves in that excited state and comes back to the ground state. And yes, it releases energy, but not at the cost of electron. So it will keep on rotating in the ground state, but it will keep on taking energy, getting excited to the higher excited state, spending that extra amount of energy taken, and then it will again come back to the ground state. Again, during this process, electron takes a time of somewhere of the order of 10 to the power minus 8 seconds. So that's why you're continuously getting energy, but that energy you're getting is not at the cost of electron. It is just doing the photoelectric effect thing with the incident energies. So this proves that Rutherford model was not entirely incorrect, and this was postulated by Bohr. NTA loves it. Let us formulate questions around it also. Now, Bohr theory is not applicable to. Bohr theory is only applicable to single electron species, my friend. Now, who is a single electron species? Hydrogen. Sir, helium has 2 electrons, so not valid. Lithium has 3, but so Li plus 2 will have 1 electron, so it is applicable. He plus 2, sir, He plus 2 will have 0 electrons. So if 0 electron, then also it is not applicable. So actually it is not applicable for 1 and 3. Therefore, option 4 will be your answer. I hope everybody is correct. I hope everybody is clear. Therefore, option 4 will be your right answer. Right? Chalo. Moving to the next one, guys. Now, the basic few formulas I'm giving you how to calculate radius of electron in nth orbit. It is equal to r naught into n square by z. Velocity of electron in nth orbit is equal to v naught into z upon n. Energy of electron in nth orbit is equal to minus e naught into z square upon n square. I hope everybody is clear with this. Now, let us revise the value of these constants also. Value of R naught is 0.529 angstrom. 1 angstrom is 10 raised to the power minus 10 meters. Value of V naught is 2.18 into 10 raised to the power 6 unit is meter per second. Value of E naught is 13.6 electron volt. 1 electron volt is 1.6 into 10 to the power minus 19 joule. Therefore, in terms of joule, E naught will be 2.18 into 10 raised to the power minus 18 joule. I hope everybody is clear with me. Now, ultimately, if you know these proportionalities also, most of your questions are done. Yeah. One more proportionality you should know, that is of frequency, because we know frequency is nothing but 1 upon time period, and time is equal to distance upon speed. So actually, just to have a ratio for frequency of radiation by an electron, speed is like velocity of electron in nth orbit. Distance, if an electron is revolving in a circular orbit, what is the distance? Sir, it is 2 pi r. So actually you need, while seeing the proportionality, you should see the proportionality of velocity and radius. Velocity is proportional to what? Sir, z upon n. So numerator will have z upon n. Radius will have a proportionality of n square by z. So this is n square by z. So ultimately frequency has a proportionality of z square upon n cube. Now, most of the students do not remember this. If you do not remember this, derive it with common sense. Else, you should remember frequency is proportional to z square upon n cube. I hope everybody is clear. Now, let us now, if you just try this question with that logic. I am giving you time. Attempt this one. Attempt this one. Answer, guys. If the radius of first orbit is x, so x is equal to r naught into, for first orbit as in 1 square upon hydrogen as in 1. So r naught is x. Then radius of second orbit of Li. So radius of second orbit of Li plus 2. R naught is x into second orbit as in 2 squared upon, for lithium z is 3. So this is 4 by 3. That means option 2. Perfect, perfect, perfect. Beautiful. Moving to the next one. I have given you the formula, so quickly solve it. Now, if velocity of electron in first orbit is v, so as in v naught is v, what will be the velocity of electron in third orbit? Okay, so velocity in third orbit. So v naught as in v into z upon n. So for lithium, z is 3 and n is also 3. So this is cancelled. So this is v. Good? Good? I hope everybody is clear. Chalo. Moving to the next one. Now, this is again the radius thing you can do. So it is a homework for you. Let me help you with the answer. Answer will be option 3. In which of the following radius of first element? Now you can do this. Obviously, it's a question for practice. So do it right now. It will not take time also. It will not take time also. In which of the following radius of first orbit is minimum? Orbit is fixed. So ultimately radius, if orbit is fixed, what is the proportionality? N square is done. So it is proportional to Z. So whoever has, you need to calculate minimum radius. So maximum nucleus. Who will have the heaviest nucleus? Hydrogen, tritium, yes, it has more neutrons. Beryllium, helium. Beryllium is the heaviest among all. Therefore, its radius will be least. I hope everybody is clear with this also. Chalo. Moving to the next one. Now, angular momentum. Bohr says what radius from nucleus is actually defined as a radius, because it is not a Dahmer or a cement road. How can you say this distance from nucleus is the first orbit? Because Bohr postulated that whatever be the radius, whatever be the orbit, in that orbit the angular momentum of the revolving electron will be quantized, and this angular momentum quantized value was multiple of h upon 2 pi, quantized as an integral multiple. So whatever orbits you have, like first orbit will have electron revolving having a angular momentum of h upon 2 pi, second will have an angular momentum of 2h upon 2 pi, third will have 3h upon, so on. So for third it will be 3h upon 2 pi. So 3h upon 2 pi is obviously option 1. I hope everybody is clear. Moving to the next one. Now, energy of orbit. Here you have to theoretically say that energy of orbit is what? Increases as we move away, decreases, or remains the same? Sir, we know through the value energy is proportional to z square upon n square. So as n increases, value decreases. But that is the significance of this negative charge. Because there's this negative charge is telling you that yes, magnitude is decreasing, but it is becoming less and less negative. That means ultimately value is increasing, because obviously we know if we give energy, if electron takes energy, it gets excited. So energy increases as you move away. and mathematically also that is signified using the negative charge. I hope everybody is clear. Guys, chalo. Moving to the next one. Now, the next question says ratio of energy of first excited state of helium and ground state of hydrogen. So first excited state of helium. So let's say for He plus, what will be the proportionality, and for, because I have to take ratio of hydrogen. So first excited state as in n equal to 2, and proportionality of energy is with z square upon n square. So for helium 2 square upon 2 square. For hydrogen ground state, so 1 square upon 1 square. So this is 1:1. Was a simple question, a doable question, but yes, you have to be vigilant with the formulas also. You have to vigilant with your handwork also, because handwork obviously will decide the more and more you practice, the more and more easily you can land with the answer. I hope it is good. Chalo, now moving to the next one. So this is a simple question to make you revise all the formulas. The formula for radius, velocity and energy I have given. Let me just give you a relation for kinetic energy and potential energy. The total energy formula that we know, which is energy of electron in nth orbit, is nothing but minus E naught into z square upon n square. This you already know. The only extra thing I'm telling you over here is actually total energy is nothing but kinetic energy plus potential energy. Kinetic energy is nothing but negative of total energy, as a negative of this value, first point, and potential energy is actually half. If you divide total energy by 2, you will get your if you divide your total energy by 2, you will get your potential energy. I hope okay, I'm sorry. If you, okay, I guess if you multiply, because total energy is half of potential energy. Remember like this. Total energy is half of potential energy. That means potential energy is twice of total energy. I beg your pardon. Everybody is clear? So if you just know the formula, which I have already told you in the previous slide, the formula for the relationship for kinetic energy and potential energy, you should know. So potential energy is twice of kinetic energy. Potential energy is twice of total energy, and kinetic energy is just negative of total energy. I hope everybody is clear. Moving to the next one. Now the next question about the hydrogen spectrum. Whenever an electron makes a transition from higher state to ground state, it is Lyman series. Ground state as n equal to 1. From to n equal to 2, Lyman, Balmer, Paschen, Brackett, Pfund, Humphrey. Lyman belongs to ultraviolet region, Balmer belongs to visible region, and remaining all other spectral lines belongs to infrared region. This is a basic information from NCERT that you should remember. Now, in hydrogen spectrum, the series of line appearing in ultraviolet region of electron. So ultraviolet is Lyman series. Now, how to calculate the wavelength corresponding to a particular transition, like wavelength of first line of Paschen series. So what is Paschen series from higher to n equal to Lyman, Balmer, Paschen as in n equal to 3. So Paschen is from higher till n equal to 3. So first line for Paschen series will be from 4 to 3. How to calculate the wavelength for the transaction? 1 upon lambda is equal to Rydberg's constant into z square into 1 upon n1 square minus 1 upon n2 square. Now, whatever be the value of n, I mean, if electron is going from 3 to 4, then it must be absorbing that packet of energy. If that electron is releasing that packet of energy, then it is coming down from 4 to 3. But the value of lambda will remain the same. Hence, for calculation, you will always put n1 smaller and n2. This is just for calculations, so that your lambda will not come out to be negative. So what is value of R? Value of R is nothing but 1.1 into 10 raised power 7 in that you will be getting lambda in SI unit as in meters. And yes, for ease of your calculation, you can also remember this, that 1 upon R is equal to 911. Remember the US, like we call the police with 100, US call it with 911. So 1 upon R is nothing but 911. I hope everybody, you will get loads of question around this. So I am, after discussing this, the calculation once you'll do, you will get this as your answer. Yes, yeah, very good, Ankit. Perfect, Ankit. Ankit is performing with us. Good. Moving to the next question. Again, a homework, the same doubt, the same question which I have given you, the same pattern which I have given you. Now, okay, let us do and solve this question. The question says, I'm giving you time to solve this. Okay. Let me pour some coffee. Attempt this, guys. Number of possible spectral lines in bracket series. So Lyman, Balmer, Paschen, bracket as an n equal to 4. Okay. Okay, I'm sorry. Ankita. Okay, I was reading it Ankit. I'm sorry, beta. Ankita. You have been very active with the reply. So I'm all the very best. Keep working like this, Ankita. You will be doing great. Yeah. Ciao. So let me see if I've got some answers. No, I haven't. So let us solve it together. Number of possible spectral lines in bracket series and hydrogen spectrum when electrons present in ninth excited state. Ninth excited state as an n equal to 10. Bracket as an n equal to 4. Lyman, Balmer, Paschen, bracket. Now, if electron is making a transition from 10 to 4, then what is the number of different spectral lines, possible spectral lines, sir? Number of spectral lines for a transaction from N2 to N1 is calculated by change into change plus 1 by 2, or maybe minus 1. Minus 1. So ultimately, what is the change, guys? Sir, change is 6. 6 minus 1 is 5 by 2. So this is what? This is 30 by 2, which is 15. Okay, we don't have that option. Okay, let me delta n into delta n plus 1. So if I do it 6, 10 minus 4 is 3. 10 minus 4 is 6. So 6, 6. Number of possible spectral lines return to ground state. Okay, beta. It is asking you number of possible spectral lines in hydrogen spectrum when electrons present in ninth excited state returns to ground state. I'm sorry. It is asking when it returns to ground state, as in number of possible spectral lines in bracket series in hydrogen spectrum when electron present in ninth is returning to ground state. Actually, the formula you can't use because the question is not asking that it is coming to from 10 to 4th. I'm sorry. No, I'm listening, beta. I was just doing that question. Krui me ne sai is sir is not listening. I am listening, beta. I am listening. The only thing is I was reading this question, and once the theory is large, you misread the question. So actually, I'm reading the question properly. The question is not asking you that electron is moving from 10 to 4th. It is asking it from 10th excited state, it is going to ground state. But you have to tell how many of those are coming to bracket series, as in how many of those transactions are happening to n equal to 4. So ultimately, we have misread the question. That's why I was reading it once more. A good question, I would rather say. So from 10th excited state, as in from n equal to 10, it is going to ground state. But you have to identify how many of them are coming to bracket series. Sir, 10 can come to 4, 1, You have to again check it like this. 9 can come to 4. From 9, you from 10 you can come to 9. From 9 also you can come to 4. So from 8 you can come to 4. You can come to 8 also, and then because you only have to calculate which are coming in the bracket series. From 7 you can also come to 4. From 6 you can also come to 4. From 5, so that is it. So how many? 1 2 3 4 5 6. A good question, a good question. But yes, they played you with the logic, with the theoretical logic. So sometimes reading the question is very, very important. Moving to the next one. Now the next question says the minimum de Broglie wavelength is associated with. Sir, what is de Broglie wavelength? De Broglie wavelength is equal to h upon momentum, because de Broglie said that wave nature and particle nature are inversely related. Wave nature and particle nature are inversely related. So wave nature is lambda and particle nature is mass into velocity. So question is asking you the minimum de Broglie wavelength. So if I want this to be minimum, then ultimately I want mass to be maximum. So who has maximum mass? Electron. So I mean it is not having the nucleus is even not considered. So obviously you can see sulfur is super heavy. So sulfur will be your SO2 will be your answer. Now moving to the next one. Now, the next question, the de Broglie wavelength of tennis ball moving of mass m, moving with velocity v per second. So actually you just have to do the calculation. Lambda is equal to h upon mv. Mass is given, but converted into SI in kg. So h is 6.626 into 10 is power minus 34. Mass is 60 upon 1000, because you have to take mass in kg into velocity is 10. So you just have to solve. Once you solve, I guess you will land up with answer 3. Good. Chalo, good. Moving to the next one, guys. In hydrogen atom, if x is radius of first orbit, de Broglie wavelength of electronic third orbit. So a very famous point, a very probable question, beta, because de Broglie said that lambda wavelength is h upon mv. Bohr postulate said that mv square upon r, which is angular momentum, is quantized. That means it is multiple of h upon 2 pi. So angular momentum is quantized. This is Bohr's postulate. If I combine this, that mv square by r is equal to nh upon 2 pi. But sir, I have mv square by r. Here I have mv. So for that you have to relate momentum and kinetic energy. We know kinetic energy is equal to half mv square, and momentum is equal to mass into velocity. So if I just calculate v from here, so v will be equal to momentum upon m, and put that v over here, so I can have kinetic energy is equal to half mass into v squared, as in momentum squared upon mass squared. So this will be cancelled. So ultimately momentum is equal to twice of kinetic energy into mass. Somebody remember that formula also, that momentum is equal to P is equal to under root of 2 km. 2 km. So instead of this, I can also write under root of 2 km, twice of kinetic energy into mass. I hope everybody is clear with this. Now, if I know this, I can relate lambda and kinetic energy also along with momentum. But here we are focused on radius. So for radius, I know what is the circumference of Bohr orbit, so 2 pi r. What is the circumference of Bohr orbit, so 2 pi r. What is wavelength, sir? Wavelength, if I see, frequency is equal to c by lambda. Everybody know it. Now if we say that electron is revolving with a circular orbit. So electron must be revolving with a circular orbit which has a circumference of 2 pi r. So how can you relate wavelength that an electron is making, the number of waves that an electron is making as per de Broglie, because de Broglie said that electron do not have, because its mass is very less, so it has a probable wave nature. So with this 2 pi r and this frequency calculation, you can easily calculate that lambda de Broglie, n times of lambda de Broglie is nothing but circumference of Bohr orbit. A very important conclusion, which is 2 pi r is equal to n lambda. Again, a very famous conclusion. You will get so many questions out of this. So 2 pi r is equal to n lambda. If you just use this in the formula, if x is the radius of first orbit, so radius of first orbit is r naught into, that means r naught is given out to be x. So if x is the radius of first orbit, de Broglie wavelength of electron in third orbit, so this lambda we have to calculate for third orbit. So 3 lambda will be equal to 2 pi r naught, which is x, into n square as in 3 square upon z as in 1. Why? Because we have to calculate it for hydrogen species. I hope everybody is good. So lambda will be equal to this 3 and this 3 is gone. It is nothing but 6 pi x. It is nothing but 6 pi x. I hope everybody is clear with this. Good question, good question. But yes, you have to remember those conclusions. If you don't remember those conclusions, then they become challenging for you in the examination. So conclusion is n lambda is equal to 2 pi r. Conclusion is n lambda is equal to 2 pi r. Conclusion is n lambda is equal to 2 pi r. Perfect, perfect, Ankita. Moving to the next one. Next question says uncertainty in position. Now this is making us revise Heisenberg uncertainty principle, which is nothing but uncertainty in position into uncertainty in momentum is either greater than or limiting value is h upon 4 pi. Now uncertainty in position and uncertainty in momentum. So it is saying position is twice. So this is twice of uncertainty in momentum. So momentum will get squared. Limiting value will be, it will be equal to h upon 4 pi. So you have to calculate uncertainty in momentum. So ultimately delta p square, I know it will be equal to h upon 8 pi. So delta p will be under root of h upon 8 pi. Delta p is mass into velocity. So delta v will be equal to 1 upon m into under root of h upon, let's say this 8 is 4 into 2. So 4 will come out as 2. So this is 2 pi. So I hope we can judge that answer. 1 upon 2m under root of h. 1 upon 2m under root of h. If uncertainty is twice the uncertainty in momentum, if this is twice uncertainty in momentum, so this is 8 mass into velocity 4 1 upon 2m under root of h. But this pi, I guess I have an option problem. Haan beta. So let us create an option for us, 1 upon 2 pi. Let us do 2 over here. So it will become your right answer. I hope everybody is good. Chalo, moving to the, it was having a misprint, so no worries. Option, we have created an option. I hope everybody is good. Chalo, now. Chalo. Next question beta. Uncertainty in position of this much gram particle is this. You have to calculate again the same thing you have to do. The formula is delta x into delta v will be equal to, because obviously it is more, but for limiting value for calculative questions we do h upon 4 pi and then m. Mass is given, but you have to put that in SI units. So mass will be equal to 0.25 upon 1000. This will be your value of m. So m we can put, pi we know, h we know, and delta x we have to calculate, and delta v, okay, delta x is 0. Minus 10 is minus 5. We have to calculate delta v. So this is just calculation. So I'm giving it as homework for you. Moving to moving to last, which is quantum model. Now quantum model was the actual model which signified, which told you that how electrons are distributed. How was it postulated? It was initially started once you had written a statistical equation on the behavior of electron. That equation is known as Schrodinger wave equation, which is this I mean, yes, those, maybe you cannot remember that equation for always, but yes, this is del square psi is the eigenfunction, which is amplitude of wave function with respect to x, y and z, plus 8 pi square m upon h square e minus v psi. So psi is the eigenfunction, the wave function which represents the amplitude of electron wave, and through this Schrodinger wave equation we have solved that equation, and the solution of these equations are denoted by certain numbers which give you the complete address of the electrons, and those set of numbers are called quantum numbers. So this is Schrodinger wave equation. You should remember this, and once you solve it, you get your quantum numbers. So certain theoretical questions regarding quantum numbers: which of the following orbital is a complete wave function represented by phi 4, 1 and 0? Now attempt it, please. A good question, I would rather say. By 4, 1, 0, actually the quantum numbers, the eigenfunction gives you solutions. The Schrodinger wave equation gives you solutions. Solutions of what? Solutions of finding an electron around the nucleus. The probability of finding an electron around the nucleus is maximum. The region is called an orbital. Those orbital are designated by a set of numbers which are principal quantum number n, azimuthal quantum number L, and magnetic quantum number M. Only these three quantum numbers are direct conclusion of Schrodinger wave equation. The last, fourth quantum number, that is spin quantum number, is not a direct outcome of Schrodinger wave equation. It was independently later introduced. So the Schrodinger wave equation just give you information of n, L and M. So which is 4, 1 and 0. So n is 4, yes. Principal quantum number is 4, no. What is L? For S it is 0, for P it is 1. So it is definitely P. So obviously answer is 4P. I hope everybody is clear. I hope everybody is clear. Sir, quantum number is in by any compound, hai? So I didn't get your question, beta. Dharma. Sir, quantum number is in by any compound. As in by beta, quantum number are the address, are the designated numbers, because statistically once you solve Schrodinger wave equation, the solution have imaginary part. The solution of Schrodinger wave equation required Laplace transformations, all those higher mathematics. We do not have to solve it, but yes, after solving, we, like the quadratic equation, you know how to solve, but those solutions, you say they are roots. So the roots are the solution. Similarly, once Schrodinger wave equation is solved, you get a XYZ coordinates of electrons, but we do not plot, because ultimately we'll be violating this principle that we are exactly telling the location of electron. That's why we combine it with mathematics, and we say that we can only say the probability of finding electron. We cannot 100% be sure that the electron will be having that XYZ coordinate because there is a variable which is time. So therefore we use a set of numbers called quantum numbers. I hope we are good with this now. Okay, so coming to some questions regarding quantum numbers. Which of the following set of quantum numbers are correct? So value of n, L and M are given. You have to check that out of them which are correct. So n is 1, L is 1. No sir, because value of L can maximum go till n minus 1. So if n is 1, L can't be 1. So this is obviously incorrect. First is obviously incorrect. Now if 2, this can be done, because value of M ranges from minus L to plus L. So this can be possible. What about third one? 3, 2, minus 2, it is also possible. 3, no, sorry, it can't be greater. So 2 and 3 are correct. So this represents a correct sort of quantum number. An easy question. I hope everybody is comfortable with this. Let us attempt this one. Which of the following value of NLM respectively represents 7py? Okay, again the same thing. 7 as in value of n. For p, value of L is 1. So 7 and 1. Now, for P, M can be from -1 to +1. So -1, 0, +1. So yes, it can't be +2. So obviously we have answer 2. Chalo. So atomic structure beta, these are the questions that you will be getting from around atomic structure in your examination. And yes, this was it from my side. Because I personally have some live classes in the evening also, so I could not be able to finish physical today. But yes, I will be finishing this physical tomorrow at 11 a.m. We'll be meeting again with the remaining chapters of physical chemistry. We'll be solving such questions, and with those questions we'll be able to revise the concepts as well. So this is me, Gaurav Singh Arora, signing off. I hope you people will be studying the complete day. Invest yourself completely and fully. If you want these lecture notes, these will be you can download them. You can download these questions in the WhatsApp channel, PW NEET English WhatsApp channel, the link to which will be there in bio. So take care. Please study with as much of efficiency as you can. Bye bye.